Reading, sir.
Okay, okay. Good afternoon to all of you. I can see
Participants 161.
There, besides the 161, we can see there are many others on YouTube. I think the youngsters are preferring the YouTube route.
okay.
One 168.
They'll be joining, but let us just have some. I'm just waiting whether our executive director, maybe he might be busy. Because he also held the COVID. He was in hospital for long.
180 plus.
Anyway, let us welcome our guest speaker of today, tomorrow, and after tomorrow, of course. On behalf of NIDM and CIDC, you are most welcome to this maiden venture into the area of man-made disaster, and this is a very much catchy word. Dr. Swaroop has thought upon this, and then National Institute of Disaster Management under Ministry of Home Affairs since 1990. Here. We have shifted to Rohini campus, Sector 29. But on behalf of our Executive Director, Major General Manoj Kumar Bindal, and also all our faculty members and staff, welcome you to this program, which is going to open up lots of windows of opportunity, as well as taking that challenge, that COVID, as well as surging demand, as well as cost, that escalation that has taken place by 40, 50, 60% of most of the building materials. In this case, when we are still COVID impact is there, but at the same time, it has given us this inspiration to take you all along with a topic. I would not say it is a topic, but it is an opportunity for all of us, rather, especially those who are joining here. More than 800 got registered here, especially by invitation. So on the bridges which are there on the road, or even in the railways, or even in metro cities, there are many types of bridges are there. So there, how to do the health assessment before they could go wrong. And that is like what we do in our case also for health assessment for anyone, like especially after 40. But these days, COVID has made us to see that anytime, any moment of our life, we have to check that what is the health status. So in that context, especially health assessment and evaluation, rather pathological as well as how it is going to serve for much longer time. What kind of predictors are there? What are the assessment to be made, and what are the tools are available? Is there any guideline? If guideline is there enough manpower? Looking at the number of bridges that we are having. So,
एक मिनट के फाइनल करें यार, उसको
in
थोड़ा
this
सा close पानी दे।
context, we would like to welcome today, especially our Dr. P.R. Sarup sir, and it is in fact last more than 3 weeks we have been under discussion that how to carry out as
उन्होंने साइन किया हुआ है, इसको भी लगा दें। हैं?
especially for our
सारा आप कमिट कर रहे हैं ना, हो गया सारा।
who are going to be our future leader, especially
Mr. Nirmaljeet Singh, Mr. Nirmaljeet Singh, please mute yourself. Mr. Nirmaljeet Singh, please mute yourself.
and we are making
Mr.
it
Nirmaljeet Singh.
that how to
लाओ
handle
इसमें एक लाइन और
or test and their how to assess and what kind of measures in terms of retrofitting, repairing, and prognosis and diagnosis have to be made, and tools and techniques.
इसका तो मैं करूँ, उसमें वो
So in this
सही से हमें क्या तमीज नहीं है इनको भी बैठ
Mr. Nirmaljeet Singh, please mute yourself. You are disturbing everyone. Mr. Singh, mute yourself.
I also got mute. Is it?
No. You are okay. But Mr. Nirmaljeet Singh is talking to several other people and disturbing everybody. Please mute yourself. Yes, Dr. Ghosh, please go on.
Yeah. So I welcome you. This I was giving a little bit of background of this as we have planned more than 3 weeks before, 3-4 weeks before that, how we came up to this area that which is going to open up an industry that we have to set up and making way out for the health assessment and evaluation of bridges on roads, railways, and metros. So I think our executive director probably he is not in a position, or otherwise, yeah, I think he is busy somewhere. But we can proceed with Dr. Sarup.
Thank you, Dr. Ghosh. And once again, may I request all the participants to keep themselves on mute mode. You can keep your camera on, but please mute your mic, because this is a discourtesy to the speakers once you start talking about and disturb the whole audience. Now we have a considerable number of people who are here, and this program is also being aired on YouTube as well as on the Facebook. So there are plenty more who are joining there. So let us basically listen to the speakers that are there and have this courtesy. Thank you so much, Dr. Ghosh. You have done a wonderful preamble. And once again, I welcome all the participants, those who have come from the industry, those who have come from basically the government sector, representing the regulatory end of it, and of course, the students and the colleges who are also participating in here. And I think it is going to be a very, very fruitful and useful meeting, what we have today. So to begin with, let me just give you a bit of a background, and let me tell you how exactly this idea cropped up in our mind. For last about couple of years, we have been watching successive failures of the bridges, which are nothing but man-made structures. They are collapsing, they are basically falling down, and many of them are falling down even though they have not become too old. So why exactly this whole thing is happening? Now let me give you a bit of a history behind it, and you will understand what we are talking about. And this issue does not only limit to the bridges, this is also going to be expanding to structures, the buildings, and many other things that we are constructing and we will continue constructing. Until about 90s, India wasn't constructing much. As a matter of fact, many of you may be surprised that in last 25 years, the amount of construction that we have done. Sangeeta, please mute yourself. Sangeeta, please mute yourself. So last 25 years, the amount of construction that we have done Possibly in last 5,000 years, so much of construction has not been. And let me just give you some of the numbers which are going to be enlightening you and telling you the extent of work that we have done in this country, which is considerable. In 1996, India used to produce not more than 87 to 88 million ton of cement every year. And today we have a rated capacity which goes beyond 500 million tons. Now this capacity has gone up almost 7 times higher during last 25 years. After all, cement is the essential commodity, and that is going to give you an idea as to how much we have constructed. You look at the roads, you look at the highways, you look at the bridges, and you look at the city centers, the housing which has been constructed throughout the country. You talk of the airports, you talk of the utility production units, you talk of the industrial units, and plenty of construction has been done in last 25 years. Now, while we were constructing all these assets in the nation, there was one element that was being ignored. We thought that these structures are going to be there forever, but believe you me, the structure is like a human. This also has a tangible life, and it definitely does require some kind of periodic check of health. It requires some kind of treatment. It requires a strengthening, like it happens in case of a human life. Unfortunately, these are the Nitesh Gupta and Mr. Maurya. Did you not listen to me when I said you have to mute yourself, please? Why are you being discourteous to people? So, the life has been very different in last 25 years. The substantial amount of assets that we have created in last 25 years are now amounting to almost like about if we take the average investment in construction as almost like about 5 lakh crores of rupees, we have constructed assets worth about 125 lakh crores of rupees. But what exactly is happening as far as the maintenance is concerned, as far as the health diagnostic is concerned? Is there a national policy? I am leaving behind this question. And I think this deliberation that we are going to be making today is going to be focusing on this particular issue, that do we have a national policy? The second question I have to say, that what are the kind of systems that have been available to us? It is not that we are writing on a clean slate. There were old systems, and I can see that there are very senior officers from Ministry of Railway also who have joined us. And let me tell you that the highway divisions, which used to come under the colloquial control of the Public Works Department of different states, and also the railways, always had a very robust system, the health of the structures that you have. Mr. Ajit Mishra will be talking to you tomorrow, and he will tell you the kind of system. I remember very clearly that there still exists a system what you call as permanent way inspector. But then now what is happening? The roads and highways are under the control of many municipal corporations, municipalities, under new smart city outfits that have been created. And do they have that system? That's a very major question. And the second question that comes there, that now with the new exigent situation and excessive quantum of construction which has been done, and even the railways and highway departments are also not bereft of that, do we have the systems available to us so that we can do it faster, we can do it properly, and we can do the kind of things that are required? My third question that I'm raising, and I think we'll be discussing on these questions. The third question is, have we taken a stock of the assets that we have? Do we know how many bridges we have in the country? In the border areas, we have plenty of bridges. You have in the civic communities, you have plenty of bridges. The highways are all strewn with the bridges that you have there. Railway networks, freight corridors, and think of anything else for that matter. And right within the municipal corporations itself, you have flyovers and you have the bridges that are there. Who's taking care of them? Do we have a stock of it? Do we have a stock of the health assessment that has been made on these structures? These are the kind of things that we have to basically dwell upon, and this is another question that we need to answer. Uh, After the stock taking, the second question that comes, that do we have enough number of experts who can handle the kind of bridges that we have in the country? Forget about the buildings. Buildings are everywhere, and you will have plenty of people who would be required. Do we have a stock of those things? Do we have the people who can conceptualize? Do we have people who can operationalize those things at site? And something very important, do we have the laboratories? Do we have the equipment which is needed for making a fair diagnosis? Have we created and enshrined the systems that are needed for making this kind of an assessment? Do we have a stock of all this information so that we can always go and have a look at it on a periodic basis? So these are the questions. You will recall that if you visit a hospital, there is a case history that is prepared of you. There is a case file. And God forbid, if you have to visit the hospital once again for any other ailment, the doctor definitely does rely on your previous record. Do we have a record like that? So these are the things that we have to do. And now let me go to the next question. The next question is that we have plenty of engineering institutions, colleges, and many professionals who are being groomed. Have we really tried to utilize this resource in this direction, which is going to be opening up new career opportunities for our young friends? So these are the things that we have to answer, and we also have to have an institutional mechanism to utilize such resources for that matter. How do we utilize the laboratories that are available with the colleges? Who are the construction agencies or specialized agencies who can implement these things? Do we have a database of all these people? So there are plethora of questions. Mr. Rajgopal, do I have to shout once again? So we have to answer these questions during this session. It is going to be a session where we will be deliberating on the issues. We will also be imparting knowledge. And when we do not have many solutions available to us, then the best thing that one does is to assemble all the people who are the stakeholders and seek their opinions and views. We have plenty of eminent people today with us, and foremost is Mr. N.K. Sinha, who has been the former, Secretary of Director General of Ministry of Road Transport, and of course the Director General there in the department. And he is a very, very experienced person, very sensitive to it. And we have been working on this particular issue for past about 3 to 4 years. There are a number of statewide seminars and conferences we have conducted to deliberate on these issues. There are some systems, but how effective they are, that has to go under some kind of an examination. We have Mr. Engineer Vinay Gupta, who's the Director and Chief Executive of Tandon Consultants Private Limited. And of course, we have Dr. Lakshmi Parmeswaran, who's the Chief Scientist in CSIR, and not the least, Dr. Chandan Ghosh himself, who's the Principal Scientist with the National Institute of Disaster Management, with whom we are basically partnering and offering this particular thing. We are looking at sequel of this particular event, where we can really go and expand, not only limiting it to the the bridges and flyovers, but also take it beyond that, and let us look at all the man-made structures, lest they become the cause of man-made disaster. So these are the kind of points that I thought I shall lay before you. And with that, I must thank once again all my participants. Another time that I'm making a humble request that as a token of courtesy to the speakers, please keep your mic on mute so that everybody can listen to what these wise people have to speak about. And I am handing it over to Dr. Chandan Ghosh once again. Dr. Ghosh, please take it over and start with the proceeding of this particular discussion.
Yes.
Thank you so much and God bless us all. Thank you.
Yeah,
Arvind Sharma. Arvind Sharma. Why would you not mute? 10 times this has been said. Please do that. You are being discourteous. Yes, sir. Dr. Chandan Ghosh, please take it over.
Thank you for this background. Rather, you have so nicely flagged. And so in this, I have the honor of going through this session with three eminent speakers. And Engineer Binay Gupta is a Director and Chief Executive Officer, London Consultant Private Limited. And also we have N.K. Sinha Sahab, former Director General, MORTH, who is going to talk about bridge inspection and documentation process, codes and guidelines. And also we have road bridges, and especially one of the things is structural health checking system. We have Dr. Lakshmi Parameswaran from Central Road Research Institute. आप सबको स्वागत है, and it is really honor for us to have you, and also having you on this online platform and bringing you in this session. And before I call upon Engineer Binay Gupta, I would just like to add one point, is that, of course, you are going to highlight, and what we have to see in this, that we are looking at our young engineers, Dr. Sharoop has rightly mentioned, and we are looking at infrastructure rating and critical infrastructure among all the things that we have made in the civil engineering profession is the bridge. The bridge is the connection between the artery, or you can say artery of communication. And so health of the bridges makes, especially from our institute background, National Institute of Disaster Management, where we do lots of capacity building program. And several such programs are there even online. You can see into that www.nidm.gov.in, or you can look into that, and anytime you can register an ongoing program, especially in the area of disaster management. You can freely register there and then follow whatever instructions are there, and then e-certificates are being used, are being given based on certain criteria which has defined by NIDM authority. So as far as capacity building in this civil engineering domain, especially on the health assessment is concerned, so this is our first attempt towards this direction, to go hand in hand in such a way that we come out with various level of infrastructure rating system, which are, very much present in other countries, but we have to go on an institutional mode in making this health assessment report, as well as the amount of money or amount of allocation of the budget that have to be made or yet to be made or explored through the various organizations like railways or whoever, PWD, NHAI or NHIDCL, and various state government agencies and construction agencies, where we are emphasizing not only capacity building and framing the guideline, but making it as an institutional process to build our infrastructure to start with the bridges. So we'll see that time to time that how we take it forward. So I now welcome the first lecture of this 3-day session by Engineer Vinay Gupta. That I just read a few aspects of him. That he is serving as Director and Chief Executive Officer in Tandon Consultant Private Limited. He is engineer from BITS Pilani, 1983 batch, and he is serving since 1987 and lately as Director and CEO of the Tandon Consultants Private Limited. So he has been actively member of various codes and standard committee of BIS and IRC. In fact, Civil Engineering Division Committee meeting is going on since morning 11 o'clock today. It is still going on. 25th meeting is going on under chairmanship of Engineer Dogra. So then his contribution includes specially India Road Congress Special Publication 65, Design and Construction of Segmental Bridges. Then IRC SP 71, very famous, Design and Construction of Precast Pretension Girders for Bridges, and many other documents he has made. And he is he has got many awards, of course, the seismic design and construction of Radisson Hotel, New Delhi, launching system for segmental bridges, precast concrete station for metro projects, which a challenge to designer and constructor by IBC, and best paper title award by title precast concrete station for metro projects, a challenge to designer and constructors by UKIERI, UK. Pre-stress concrete design award 2013 by Institute of Engineers India, and also S.B. Joshi Memorial Award in the year 2019. So Engineer Vinay Kumar Gupta is also Vice President of Asian Concrete Federation and Vice President of Indian Association of Structural Engineers. So you are, Gupta sir, you are most welcome to have your important presentation here, where we have more than 300 participants. Of course, they are going to add. So please accept on our humble welcome on behalf of this NIDM and then CIDC.
Thank you, Professor Ghosh. Only I noticed that every now and then my mic gets muted. So in case I get muted, please prompt me so that I can unmute. Okay. So first of all, I'm thankful to CIDC, NIDM, ICC, and CENCR. And special thanks to Dr. P.R. Swaroop, Major General M.K. Bindal, Professor Chandan Ghosh, you sir, Mr. Prabir Bhattacharya, who has been instrumental in getting me in here. And I hope I don't disappoint this large number of audience because I'm delivering the first lecture. Well, but let me tell you, since I'm a consultant, I'm a good link between the construction and the design. And therefore, my entire presentation over the next 40 to 45 minutes is from real examples, real life examples. So I'll try and share my screen if it works. And then, of course, I am disabled for screen sharing. Can somebody help me out? The organizers, please.
Lakshmi, please take care of it. Lakshmi, please take care of it.
Yes, sir.
Okay, yes, now it seems to work.
Yeah.
All right.
Yeah, perfect.
All right. So do you see my screen?
Yeah.
Yeah, thank you so much. So, friends, we are talking of man-made disaster. I know that's the main topic of the conference today, but I have slightly modified my topic to say of large number of present-day failures, and there's a reason behind it. If we date ourselves back to Stone Age, in the Stone Age, we had nothing. So there was no question of disaster because we didn't make anything. Today we are in an age where we have developed so many things. Like we have reached out of 3 billion tons of cement, as Dr. Swaroop said, India alone is producing 1/6 of it, which is 500 million tons of cement. So definitely 1 out of 182 countries is producing 16% of the whole world is certainly great in a way. But of course, when you do something, there are bound to be some failures. I don't say that we should have failures, but what I'm trying to say is that failures will be there, but we have to reduce the numbers, we have to reduce the severity of these failures, and we have to reduce the effects or rather disaster that takes place or the casualties that take place from these failures to a least possible extent or reduce it to the maximum extent, let's call it. Of course, I'll walk you through some examples, but what I feel is that these failures are because of certain reasons, and we need to understand these reasons, and then so that we can treat it better. One of the things that I have seen in my last about 37, 38 years of career is that lack of understanding of the codes of practice. Of course, Professor Ghosh rightly mentioned about this segmental bridges, the SP65. He talked about retention girders, guideline, and all that I prepared for IRC, along with, of course, my committee. Still, I have seen that many people, do not know what is inside. They do not understand what has been prepared, and what has been updated is also not known. So we will see some examples how it happens. Understand underestimation of construction loadings. Let me tell you, this is important not only in bridges, but also in buildings. And I'll give you some example of that as well. That if you do not take care of this aspect and design the structure only for the service conditions, it may not be fine. Improper construction sequence. Now, this is also important in bridges and buildings both, but yes, my focus will be mainly on bridges, that how a sequence of construction can affect our structure adversely. Then we talk of inadequate quality control. I think we all talk about it quite vocally, and a lot of things are in vogue, but finally we see that this has been a big culprit behind our failures. An improper document control. Invariably, we will find that revision R2 has been issued by the consultant, but the revision R1 is being used at the site. And the old revisions are not marked obsolete. If you go back to ISO requirements, ISO tells you that any old document must be marked obsolete so that nobody can use it by accident, and make sure that every copy is marked obsolete. But in a simple thing like this, many times we fail. And these can also result into any kind of disasters or failures. Now look at this 2017 version of IRC 6 code for loadings. How many of us know that in certain conditions, this kind of a heavy loading called a special vehicle on the left side of the page has to be taken for the design? How many of us know that something called vehicle congestion factor, which is as much as about 1.7 times of the normal loading that you take, needs to be taken into account? And this can lead to failure also at times. So let me just put the pointer option and I go to laser pointer. Okay. Why is it not turning to the next slide? Yeah. So these are the codes I think Professor Ghosh was talking about. That is guidelines for the segmental design. And I have seen in some examples that people are not using it. And they're using by simple our IRC 112. Or this guideline for seismic design, which is using capacity design methods nowadays, which again people may not have made note of. Yeah. So let's take an example. It comes from southern India. It's a physical example. Recently in my hands, I am taking care of it. I mean, in terms of investigations. We have a box girder. In the box girder, we have a cross diaphragm at the pier cap level on top of the pier cap as a part of the superstructure. In the diaphragm, of course, we have this kind of openings which are 800 by 800 or 9 by 900 millimeters here. And what happens is that there are various conditions in which the diaphragm is supported. During construction, it is supported at these two locations. During certain conditions, it is supported here and here. In the permanent conditions, it is supported here and here on the permanent bearings. And when you do the lifting of the structure for replacement, you're supposed to put it on these jacks here. Now, diaphragm for this purpose is extremely important to design for these conditions, because diaphragm may look like a simple deep beam, but the fact is that it carries a lot of stress. It carries a lot of tensions and compressions, both, even in the membrane part of it. And of course, we do analyze it as per some finite element analysis, 3D finite element and grillage and so on and so forth. And I have seen in some cases that people have not known the seriousness. They need education. And I have seen that especially happening at the site. And because of this, n number of cracks are developed in the structure. Now here, for example, if you see this picture, this is the plan of the soffit slab, the bottom of the bottom slab. And you have longitudinal cracks that have been developed like this. There are deck bottom, that is upside of the openings that we saw just now, or there are sides and soffits and this and that, not side, of course, side, top and bottom. So what has happened is that each diaphragm out of the 60 over spans that have been erected and pre-stressed have developed these cracks. What do we do? Yes, we'll call it man-made disaster. Though, of course, nobody has, there's no casualty or any such thing like that. Okay, let's talk of a building. In a building, when you're constructing multi-stories, and of course, this picture comes from this Radisson Hotel building at Mahipalpur in Delhi, which I designed about over 30 years ago, is that if you're constructing a particular floor, the in situ floor, the loading of this concrete has to be transferred to the floor below. But has anybody checked whether this floor is capable of carrying this load? If it is not capable, then I must support this also here. So if you see the picture on the right hand side, there is a deep transfer girder that has to be supported. And we have given in our own design, in our own design drawings, that look, your supports for this deep structure has to be over 3 floors, which means floor number 1, floor number 2, floor number 3 must support it. Otherwise, this floor alone cannot take it. So when we design something and submit and sort of deliver it to the site or whatever, now we should become a contractor and see that if I have to construct, what all I will ask. And one of the questions that will come as a contractor in my mind is that, look, how is this going to be, this heavy weight going to be supported? There was also a collapse of a few floors in a building in Bangalore, multi-story, where in the case of flat slab, several floors came down for whatever reasons, but there can be similar reasons also. All right, if we talk of sequence of construction, this is a case of a segmental bridge, which is spliced girder system. Now, in the spliced girder system, which is also covered in my IRCSP 65, there are several of these segments of the I girders to make a total span, in this case, 45 meters. And there will be in situ joints here. Now we have to impart the pre-stressing. In imparting the pre-stressing, there are two possibilities. One, that we impart the pre-stressing on this girder alone section, and thereafter we cast the deck slab. In this case, the pre-stressing majorly goes to the girder. The other method can be first cast the deck slab, let all the deck slab weight also come onto the steel girder, and thereafter we impart the pre-stressing to the composite section. So this sequence has to be known. It has to match with the design, only then construct it in that style. All right, oof, it's not moving. Yeah. Now we have erected something, some girders, which is very common. Girders are very common, but also very common with the girders is stability. these girders have the tendency to fall off. And for controlling the falling off or the overturning of these girders, they had to be stabilized right in the beginning from the first girder onwards. And there have been umpteen number of examples where the girders have fallen. So what we do, the very first girder, this is of course a picture from this Delhi-Gurgaon Expressway, pre-tension girders. That very first girder, which is here, once it is placed on these supports, first it is stabilized with the inclined bracings. Then second girder, once it is placed, it is connected before the cranes are released. Before the cranes are disengaged, they are first stabilized. Then the third one, fourth one like that. And last one again for additional safety have been stabilized. Similarly, if you see this picture, in this also in a different manner, the girders have been very nicely stabilized. And this is a picture from another project in Delhi, which is not Ghazipur, it's near Akshardham, the flyover by DDA. The other thing that is also important at the time of girders is the transportation. There have been cases where the bottom of the girder has received cracks because people did not put this spreader beam that you see. Now, when this fellow pulls forward, the tension comes to the girder, especially at the bottom where it is connected and it is under friction. And here, and this tension can cause cracks in the bottom of the girder. So in this case, if you notice, the two of them have been connected through a metallic beam so that all that tension goes to the metallic beams, but the supports are essentially only here and only there, not in the middle, otherwise the girder will crack up, hog up and crack. All right. This is one more example where we found that in a precast segmental bridge, the concrete at the bottom in the precasting of the segments was weak. As a result, during the construction, when the pre-stressing was done, which is majorly compression at the bottom, and the concrete could not take this compression, concrete kind of crushed, and crushed concrete led this structure to hog up by almost a meter here in this case. And of course, once that happens, yeah, this is another close picture of the same thing. One can very clearly notice that the bottom side is fairly weak. And since the bottom side is weak, it has hogged up, obviously, because there is compression here and there is a tension on top, and it has happened. Now, once this happens, then of course you have to do many things. You have to support, you have to, after providing the support, then you have to lift up each, cut off each segment, lift up each segment, remove the segments, and start putting the new set of segments. And in case the launching girder is available right next, then you use the launching girder, move it backward. Having moved it backward, lift up all the segments, just undo the whole process or reverse the whole process which you did during construction to take these segments away. And mind you, even taking these segments away or dismantling a structure like this, which may be having a span of 40, 50 or 60 meters, is equally important, equally tricky as like a construction. Another example wherein similar thing has happened, that is the bottom side is weak in concrete, but it is so weak that as opposed to hogging up, or maybe it hogged up for a while, it has finally fallen down to the ground. Another picture, I think author of this photograph is sitting amongst us, Mr. Alok Bhamik, that this is a metro project in Mexico, which they say is the worst disaster in the last 50 years, wherein the girder slab structure has fallen down due to design and construction errors. And it is of course under investigation, so we should not say for sure as to what the reason is, but it is said to be primarily design and construction both. So this is just one more picture of the same kind of a failure. Later on, of course, they have provided these steel brackets and all to support it. Maybe temporary, maybe permanent, I'm not certain. The investigations are going on. So nowadays, if what I notice is that lots and lots of projects or structures are coming in wherein investigations of this region are taking or wasting, I would say, time of the technocrats. This should not happen. Certainly, we should make sure that the structures are safe in design, in construction. There's a complete matching, complete camouflaging, And therefore, we don't have to sort of invest our or spend our energies in investigating the reasons for the failure. One of the other things that we have seen commonly is that the segmental structure, the joints, they look as neat. Mind you, they should not look neat like this. It almost shows that there is hardly or practically very little epoxy in the joint. It should look as ugly as this one that we see here on the right side. Epoxy is oozing out, and that is what we have to do. Later on, to make it look better, scrape it off, but it must ooze out. That means you have filled up enough epoxy. We are supposed to fill up 1 mm on either side of the surface. After temporary pre-stressing, after squeezing out the epoxy, it should become about 1 millimeter. That means as much of epoxy must come out. If not 50%, maybe 30% would come out and show up like this on the surface. Then we scrape it out later on. But this kind of a neatness is not advisable. All right, so these precast segments, they had to be match cast during construction, which means that one segment is cast, second segment is cast against it, and they are given a unique numbering so that the two surfaces, although in terms of design, they are supposed to be the same, but they may not exactly be the same. But in this case, they will be exactly the same, or they'll be matching with each other, so that during the construction or during the erection, they fully match and not have any kind of a stress concentration. So many a times we construct the segments like this. We may do S1, then we may do S2, then S3 and S4 like that. Sometimes we may do S1 and S3 and S5 and all that, and do the middle ones later on. Any sequence may be used, but all this is more or less completely match cast construction of precast segments. So as you notice here, this kind of unique identification numbering for each segment is given, which means even if all the spans are same or many spans are the same, the segments of one particular span are not permitted to be used in another span, because they must be used against the same segment against which they were cast. That is very important, and it has to be maintained. When you prepare a so-called SOP of the site construction, you write this. And this kind of marking is given, which tells you what is the span number, like P3, P4, and which segment it is, SS3 or SS2 or 4 or whatever. Which side is SS5, which side is SS4 or 2. That should also come on the segment marking, and it is really there in this structure that you see. We'll take one more example, and please don't mind if somebody is involved in this, but there was an argument, and I'll give my views to you. Is that we have a continuous structure over, in this case, 1, 2, 3, 4, 5 spans of 36 meters. In a continuous structure, typically when we put it on bearings, most other piers will have free bearings, but one pier will have fixed bearing. That's a normal case. Now, in this case, we have 4 bearings here and 4 bearings on every pier, including at the fixed pier. All these 4 bearings longitudinally should not be restrained. Only 2 bearings of a row should be restrained. The other 2, they should not be restrained, because if they are restrained, then we'll have 2 lines of bearings restrained, and between the 2, whatever breathing takes place, that is the expansions and contractions of the structure, will either damage the bearings or they will get damaged themselves. So it should be avoided to have 4 bearings as longitudinally restrained here. Rather, only 2, that is 2 bearings of one line, should be longitudinally restrained. But I don't say that people are always following it. Some people like it this way, but I have my views here. There have been cases where the bearings are placed upside down. And I have seen a bearing like that. And once you reach the site, you realize that in a large project with having a 200, 500 spans, people didn't see that one of the bearings is upside down. They forgot to see. Sometimes the bearing has been rotated by mistake 90 degrees in plan. That means what is supposed to be longitudinal has become transverse. This has happened recently in a project again, and we are trying to set that right. Sometimes it has been seen that the structure is on a slope Although fillets are supposed to be horizontal, but people did not provide temporary locking in the bearing, and there's an earthquake during construction, and all the bearings are free in that particular span because you are probably constructing simply supported and thereafter making them continuous later. And the structure may start sliding, not sliding to fall, but sliding away from the position. So these are some of the things that can happen. For the precast segmental structures, there are majorly three ways of erecting. One is to use overhead launching girder, which we see very commonly. Other is to use underslung launching girder, which also we see less common, but we do see. And third is we use ground supported staging to support the precast segments and put the epoxy and pre-stress and all that. So this is one case of a flyover where was constructed like this and flyover had a failure. So this is a picture after the failure. There are all these piers. These are those trusses that we saw just now in the previous picture, which says that they are supporting the segments. And this happened. Why it happened? Again, why we are using precast segmental structures is because we want to protect the segments from collapse.
Sir, please unmute yourself. Sir, you become a mute. Unmuted, sir.
Unmute your mic. Uh,
Actually, sir, you are not audible. You are not audible, sir.
Okay, am I audible now?
Yeah.
Okay, so what I will do, I'll share it again. Okay, is this visible? Can somebody confirm if the picture is visible?
Visible.
Okay,
Yes, it
I'm
is.
sorry. I'm sorry for the inconvenience. So when a failure happens, I hope the previous picture was available. When the failure happens, idea is not to criticize people. Idea is to understand from those failures as to what we need to correct for future. So here, if we see what was happening was that there is a slope in the ground to the tune of almost 11 meters till here. These are the supports for those trestles, metallic trestles, which were supporting the superstructure, which is precast segmental during construction. And a water pipeline, you notice a water pipeline, these two lines, was being laid over the slope. And these people who were laying the water pipelines, they brought the pipeline all the way up to the foundations of the trestles, the temporary foundations. And there was a heavy rain, downpour, and that rainwater, they're supposed to, every evening when they go back, they're supposed to close the water pipeline, end of the pipeline, till where they have worked. And this pipeline was also being installed. So they're installing in pieces, and they're supposed to close the ends of the pipeline when they leave, which they did not. They thought, how does it matter? We'll again work tomorrow. Anyway, we have to continue weld and all that. And it rained very heavily. The water came gushing from this 11-meter height down here and undermined the foundations. In a public project, as we say, bridge or flyover, even these problems sometimes can be so severe that some other agency doing some of the work has caused us trouble and our flyover has fallen down. Who's responsible? That's not the intent here, and that's not important. What is important is how to make sure that such things don't happen. Come to this foot over bridge. I think many of us know about this, and I don't mind discussing it. This foot over bridge, which has an arch over it, arches supposed to support all these metallic beams, transverse beams, outriggers, which are connected to the suspenders, and so on. All of them, they are supposed to be welded properly, and after they are welded, only then the concrete deck slab at the footway level is supposed to be laid. The weight is supposed to come only then. But what happened was that even before uh, full welding was done, only tack welding is done, and to make sure that the levels are all fine, and then you leave it to a welder who does a full-fledged welding. And again, it's an interdisciplinary or inter-agency coordination that perhaps lacked. And as a result, the concrete was laid, all the weight was mobilized, and tack welds could not take it, and the whole thing came down. Now, when we do this suspension business, let's say we use Macaulay or Dividag or whatever for stainless steel suspenders, etc., they have this nut and bolt system here to connect the structure to the suspender. Now, this nut and the bolt has only half extra thread. So it's very important that all the threads are perfectly engaged with half coming out. That is how they made the system. If you've forgotten to put the last thread properly and not engage it completely, it can open out and have this kind of a thing. This may not have been the reason in this particular structure, but this can happen. And if one opens out, other one slightly opens out, third one opens out, they all open out, the structure goes down. Again, only learning from failures. Look at the code IRC 6. When we design a foot over bridge, here in this case, if you see this foot over bridge having a span of 35 meters plus another 35 or 37 meters, we designed about 12, 13 years ago. These foundations are supposed to be designed for a vehicle collision load force, horizontal force, to the tune of 50 tons, 25 tons, or 10 tons, and all that. Provision was different in the earlier code at that time. It has been a little bit modified in 2017. Unless and unless you find that from the curb, the foundation is at least 4.5 meters away. If so is not the case, then this has to be designed for collision loads, longitudinally and transversely. That means if a vehicle flying at a speed of 60, 70, 80, whatever, on the main road collides with the pier here or column here, the whole bridge should not fall at all. So in this case, when we started designing, we found that we had to provide this kind of a heavy crash barrier with foundation. Only then we could satisfy the designs of this little FOB. I don't know how many such FOBs have been designed to this tune. To my feeling, very few, hardly few. People just put a pipe, they read something, and they don't care whether the pipe is safe as per the code or not. Now, this is when I say knowledge of codes is lacking. Oh, I'm taking a very interesting diagram from the code which Mr. Alok Bhaumik, who's amongst us, has prepared for IRC. Is that continuous bridge? When you have a continuous bridge and if you're supporting it on the bearings, one of the problems that may happen is that a bridge can have a toppling, and due to toppling, there can be a failure. And there have been many cases where bridges have fallen down due to toppling. Now, toppling, when you make a check for toppling, what is important is that this line from this bearing joining the other bearing becomes the chord line, and you have to see your arc and see what is the centricity and check for the stability, overturning, and all that. But also important thing is that when you calculate these loadings, which are outside of this are the overturning moments, the area of the structure should be properly taken, because the area of the structure for the same length outside here on the upper side in the picture is higher than the lower side one, because lower side has a trapezium of a reducing nature. Upper side of here is having a trapezium of a increasing nature in the size. Many times people forget this or ignore this. The other thing that Mr. Bhaumik has prepared here is that when you have a continuous bridge and you're putting a bearing system and you have a restrained bearing somewhere, let's say fixed free bearing or a pin bearing, restrained bearing somewhere or guided bearing somewhere, the direction of this guide as to how you place is extremely important. Supposing if this is a guide bearing we are talking about and this is a fixed bearing we are talking about, it has to take, and we are talking about how to place these or how to place these from wherever the fixed one is. Let's say a larger picture, from wherever the fixed one is, the bearing should be placed in such a direction that orientation and plan that the free side is along this chord line, or in this case the free side of the bearing is along this chord line, the guided side or whatever. In this case, it is this. So you have to join a straight line, a chord line, and make that as the direction of the bearings. Otherwise, the bearings may fail during operations, during service. Some people may try to place it circumferentially. Somebody may by mistake place it radially. No, it has to be along this chord line. So if we remember all these things, not only the designers, but also the site people, it's very important. Then such kind of a failure should not take place. Okay, so this is from again a flyover in Delhi. We say that for every special activity, you better prepare some mock-up. If mock-up works fine, then you say your structure is going to be fine. So what happened? They prepared a mock-up for a simple pier like this, which has a mushroom kind of a shape. It has the recesses. So ins and outs are there, which you see on the surface. And to make this mock-up, paid mock-up, of course, which was compulsory before the main construction, they made two-piece shutter. And they made a two-piece shutter for the pier, and they poured the concrete, let it harden, and thereafter tried to remove the shutter would not come out. At the end of the day, they had to demolish with the help of jacks, cranes, etc., and remove it from there. Then we all looked at the things as to why it happened. So finally, it was devised into four pieces, the shutter, a slight change of angular inclinations of these recesses so that it can logically come out, and it worked. Now imagine if this thing happened at the actual site, just 200 yards away only, and pier had to be demolished like this. The whole media will be running business out of you. We don't want that to happen. So these are those recesses I'm talking about. I'll, I think, skip this because I'll be short of time now. Okay, so we have seen several failures. Let us look at some remediation. When we have cracks like this, we are often confused how to fill the cracks. Also, we are confused why to fill the cracks. Structure has submitted to the action. It has cracked. It has released the stresses. Why do we need to fill the crack? Two reasons. One, that once you bridge the crack, once you seal the crack, you make a continuum of the concrete once again, so that it has a better strength for the future loads to come. Secondly, once you fill the cracks, it becomes durable enough equally as it was earlier, because if it's open and all that, ingress of the atmospheric carbon dioxide, etc. will take place and corrode the steel. Now, sealing of these cracks, if they are less than 0.2 millimeters, there is no point in trying anything. They are anyway less than the design values of the cracks in most cases. Just make a V groove. In the V groove, simply fill epoxy putty to seal the crack from top, because no other filler will go in the pressure, under pressure. If it's more than 2.2, sorry, and something like 0.8 millimeters, yes, you can go for epoxy grout under pressure. You can go for PU grout, polyurethane grout under pressure. If it's more than about 0.8 or 1 mm or something, then you can decide whether you want to grout cement with cement or maybe still continue with the epoxy. So those are the things to be taken care of while sealing the cracks. When a failure has taken place, failure does not mean collapse. Failure means some failure. Then we have to provide many times, or in the most of the cases, I would say, external reinforcement, which can be passive, means non-pre-stressed or pre-stressed. It can be metallic or it can be non-metallic. When we talk of metallic, we can take this famous example of Thana Creek Bridge, wherein this kind of external pre-stressing was provided after seeing lots of distresses in the bridge. That was a major distress repair. Look at this Sharavati Bridge in Karnataka, something like 30-meter span, resting on these hammerheads and all that. This bridge had several problems like corroded reinforcement, badly corroded one can see due to porous concrete, corroded pre-stressing strands, badly corroded, and leaching, etc., which was taking place. Even endoscopy was done into the ducts. That means the endoscopic camera could enter the ducts to take this kind of photographs of the pre-stressing strands. That was the condition of the bridge. They did the same thing. They provided, after all the repairs and gunniting and this and that and patch up, etc., they finally provided external pre-stressing also. And this kind of hinge are very commonly in sight for in the old bridges, which would have given way or they would have corroded and they don't know how to replace it. The other method is to go for non-metallic pre-stressed or non-pre-stressed reinforcement externally again, wherein you have this kind of fiber reinforced polymer which you place, which can be either pre-stressed or non-pre-stressed also, and they are epoxy bonded to the structure. So this is a pre-stressed FRP, as we notice here. There's a code IRC SP 40, that is this 40. There is also IRC SP 80, that is this 80. Both these talk about using this kind of this resin, pressure grout, fine. Let's see advanced composite materials. That is these FRP and all those things. They are permitted. Although they don't give you how to design, but they are permitted. In a particular bridge, we found that above the openings, there were this kind of cutouts. Above the opening, there were this kind of cracks. And vertical crack means it is falling short in the reinforcement horizontally like this across the crack. So that was definitely the issue. There were also some cracks along the web like this. Definitely there was an issue that horizontal reinforcement was lacking both here and here, or bond or anchorage was lacking. So one option that was worked out was to provide this kind of external pre-stressing of the diaphragm on both faces of the diaphragm and strengthen it. But later was a work, what was actually used was this kind of a FRP system. For each of the deficiency, FRP was provided. The required amount of force to be generated was given to the FRP supplier agency. They designed it, it was proof checked and also provided. It is besides the fact that the particular structure, the owners did not accept and they demolished it and they may ask the contractor to make a new one. And once we do all these kinds of different techniques, that is, call it FRP, call it external pre-stressing, the best thing that we should do, or the maximum that we can do, is to carry out a load test. After load test, you find out that the structure still is elastic under the application of the loads equal to the applicable highway loads. And that means you go up to 100% load, then unmount the load, keep it for 24 hours every time, and see that the recovery of the deflections is at least 85% as per IRCSP 51, I think, for the testing of the load testing of the structure. So once you have done this, you have reasonably ensured that structure is safe enough. Of course, you can't test it for seismic forces. You can't test it for wind loads or many of the horizontal forces, but you have reasonably ensured that at least for the permanent vertical loads, the structure would be safe. So idea basically was that to say that, yes, we are the people who are making structures. We are the people who are causing disasters or call it failures, but we are the people who can control the failures as a preventive measure and also as a post intervention measure. But in both the cases, it is we, it is us, it is our knowledge, it is our care, which is extremely important to take input to make sure that the failures don't take place. Thank you so much.
Thank you very much, Engineer Gupta. You throughout your life, after you pass out from BITS Pilani, then you have devoted so much of time that which has made you to talk with the structure that you design and you prepare the guideline. In the beginning of your lecture, you have mentioned about that even though specifications are there in many of them that where you are part and parcel in BIS as well as IRC, and but your concern, which is very rightly you have mentioned, that it is not, people are not able to follow, not that following, they are not able to follow. So throughout your presentation, you have shown that it is not only that design is important, but also while erection, or you have shown many case studies that where things have gone wrong, but you try to make them again correct, and what are the repair measures to be done using epoxy, where what is missing during erection process, and some of the example from Mexico as well as from Delhi, which is famous, that you have shown that that cable bridge arch rather, that which has failed, and what is the reason, and especially pointing out that special bolt, not bolt, where sufficient threading was not there. engineer a class like this, that you have noted all those things and presented before us, before the audience here, that where it has gone wrong, where they might go wrong, or how to correct it. And finally, in your last lap of the lecture, you showed that after you are suggesting that what are the correction measures to be done, and those correction measure has to be locally tested, certifying certain specification already given in IRC. So that way, you see, design, construction, then checking it whether it is erected or not. Even during erection also, your lifelong experience as on today, to correct them and to make that what you have made, you and your group and team, that in the design engineering office to the construction site. And when contractor or someone goes, they are not able to guide themselves, then you also take part based on the tenets that you have defined in your guideline and correcting it. That is something that a lifetime involvement, that which we wanted to we saw in you. And so thank you very much for such a fantastic presentation.
Thank you, Professor. I didn't know that somebody will pay so much attention to my lecture, my presentation. Thank you so much, Professor.
It is all open to the open world through YouTube video and everyone. Dr. Sarup has made it that no, it is to be available to everyone. In fact, side by side, our many participants are taking, they are looking into, they can have a view. It will be there always in the website or in the YouTube channel also, CIDC website also. So I was checking into the chat box, but एक तो chat box में मैंने बोला था क्या, कुछ participants ने बोला सर कुछ हिंदी में भी बताएं. मैंने कहा अभी मैं तो अभी help नहीं कर सकता. There are many non-Hindi speaking person are also there. So, but anyway, I said that okay, we'll see to the extent possible, but we cannot justify either way.
सर आपने पहले बोला होता तो मैं इंग्लिश कर सकता था. इंग्लिश
नहीं, वो मेरे बोलने पर नहीं है, वो तो participants there are more than right now we can see here more than 200 220 30, तो उसमें पूरा all over India और सब जगह से है, इसलिए I did not force you, but हम ये कोशिश करेंगे, ये जो लेक्चर जब हम इसको हम CIDC के थ्रू इसका जो आजकल वॉइस ट्रांसलेशन इनटू हिंदी और मेनी अदर रीजनल लैंग्वेज, ऐसा करके हम हर एक लेक्चर को फिर YouTube में डालेंगे. जिनको जो वर्जन पसंद है वो उसमें आ जाएगा, एज ए स्क्रिप्ट फॉर्म में आ जाएगा.
Very nice, very nice.
So that way we will try
at
to
the end of the day we must understand, that's it. Very nice.
Okay. Any कुछ, let me see, chat box में दो है. Sir, your views on old railway. एक Mr. R.R. Moria साहब ने लिखा है, your views on very old railway bridges vis-a-vis current codal provisions on adequacy aspect. आपका कुछ वो चाहते हैं your
Yes. I think there is a presentation by somebody from Railways, Mr. Ajit Kumar or some name I heard. Normally, he should be a better person to talk about specifically about the railways.
We will be talking tomorrow, sir.
Yes.
And for your information, there are over 400 people on YouTube right now.
Right,
besides the
right.
there.
Right. But railways, I must tell you, has the best, at least in India, the best surveillance system to see that the bridges are functioning fine, and inspections and all the recordings, they're very thorough and regular.
Okay. From my side, just only we have 1-2 minutes time. These days, there are a number of surveillance systems have come up, even LiDAR camera or even drone mounted camera, like you have shown in that arch bridge which has failed. Now, maybe with such kind of camera survey, things can be checked which knot is going to unscrew, or which is sufficient, not sufficient, even during erection or after erection. Now, digital construction is a new buzzword coming up. What is your say on that, especially about the inspection during and after in the lifetime of many of the important bridges? Where
Yes,
do
sir.
you think that world should go?
Yes, sir. My feeling is that this is a very good technique that people have devised, that they use drone with a camera, and they can go places where manually it's very difficult.
Yeah.
If I have to inspect a box of a structure which is 200 meters high or 100 meters high and some 3-4 kilometers long, external inspection at least one can do very easily, very comfortably, keep watching on the screen, and things like bearings, which are many times a culprit of the failure,
Yeah.
can be inspected very well. But for inside, we still have to go manually ourselves. So
Yeah.
it's a combination. It's like allopathy and homeopathy. No technique is complete in itself.
Yeah.
चंदन बाबू, जो हमारा लोग हिंदी में बैठे हुए हिंदी का सुनना चाहते हैं,
Yes, sir.
उनको एक मैं ब्रॉडली समराइज करके बताता हूँ कि हमारे जो एक्सपर्ट हैं इंजीनियर गुप्ता साहब, उन्होंने क्या कहा था, और आप सब लोग ध्यान से इसको सुनिए। इसमें दो एस्पेक्ट हैं। देखिए, मैंने शुरू में बताया था कि जैसे आदमी का शरीर होता है, उसी तरीके से जो स्ट्रक्चर हम बना रहे हैं, चाहे वो ब्रिज हो, फ्लाईओवर हो, चाहे वो बिल्डिंग्स हो, वो भी आदमी के शरीर के जैसे ही होते हैं। शरीर में दो तरीके की कमजोरियां होती हैं, याद रखिएगा। पहला होता है जो कि जिनको हम बोलते हैं कंजेनाइटल डिफिकल्टीज, मतलब जो पैदा होने के समय में कमजोरियां बच्चे में आती हैं। आपने देखा होगा कि बहुत से बच्चे होते हैं जिनका कि हाथ पैर टेढ़ा होता है या कोई और कमजोरी होती है। और दूसरी कमजोरी वो होती है कि जो स्वस्थ बच्चा होता भी है, अगर उसका ठीक से मेंटेनेंस ना हो, मेंटेनेंस का मतलब कि उसकी अगर देखभाल नहीं हो, मेडिकल चेकअप नहीं हो, तो वो कैसे काम चलेगा। तो उसका भी स्वास्थ्य जो है वो आखिर में खराब हो जाता है और समय से पहले वो नुकसान पाता है। तो गुप्ता साहब ने आप लोगों को जो चीज समझाई है, वो बहुत ही विस्तार से ये बताया है कि कंजेनाइटल जो कमजोरियां होती हैं पैदा होने के साथ स्ट्रक्चर के, वो क्या कमजोरियां हैं और किन कारणों से हो सकती हैं। अब इसमें उन्होंने आपको 3-4 मुख्य मुद्दे बताए। पहला मुद्दा बताया कि आप जो हैं वो उसका डिजाइन ठीक ढंग से नहीं करते हैं, एक तो ये कमजोरी है, तो उसके लिए आपको समझ होनी चाहिए। दूसरा क्या होता है कि जब वो डिजाइन हो जाता है, तब आप जब उसको बनाने जाते हैं, तो बनाने के समय में किन चीजों का ध्यान आपको रखना हो। ऐसा ना हो कि आप टेढ़ा मेढ़ा जो एलिमेंट बना हुआ है उसको टेढ़ा मेढ़ा रखें, ताकि जिससे कि वो टूट जाए या उसमें स्ट्रेसेस पैदा हो जाएं। तो इसके ऊपर कैसे ध्यान देना चाहिए। और फिर सबसे अच्छी बात बताई उन्होंने आपको कि अगर ऐसी कुछ खराबी भी हो जाए तो उसको ठीक कैसे किया जा सकता है। जैसे कि हम सबको कोई ना कोई बीमारी हो गई, कई दफे होता है ना कि गेम खेलते खेलते हड्डी टूट जाती है, तो डॉक्टर साहब जो हैं वो उसको बैठ करके जोड़ते हैं, हड्डी को बांध के प्लास्टर लगाते हैं ताकि वो हड्डी फिर से नॉर्मल हो जाए आपकी। तो ये चीजें गुप्ता जी ने आपको बताई, ये उनसे जुड़ी हुई हैं जो कि उस स्ट्रक्चर के बनने और बनाने से पहले या उस समय आपको ध्यान देना है। अब जो अगला आप सुनेंगे और लोगों से, वो ये सुनेंगे कि जब स्ट्रक्चर बन चुका होगा तो उसको किस तरीके से उसकी सेहत को आंका जाए। इसको हम बोलते हैं फॉरेंसिक स्टडीज। फॉरेंसिक का मतलब है कि उनकी इतिहास क्या है, जो चोट लगी है, परेशानी हुई है, बीमारी हुई है। जैसे मैंने एक उदाहरण दिया था जब मैं बोल रहा था कि हम अस्पताल जाते हैं, अस्पताल में डॉक्टर साहब जो हैं वो हमारी एक फाइल बना लेते हैं। जब एक दफे वो चेक कर लेते हैं तो वो उसमें सब चीजें दर्ज करते हैं कि कौन से टेस्ट हमको कराए गए, क्या बीमारी थी, हमें कौन सी दवा दी गई, क्या हमारा टेम्परेचर बढ़ रहा था, या हमें दस्त आ रहे थे, या हमें उल्टी हो रही थी। ये पूरा लेखा जोखा जो होता है वो उसके अंदर लिखा जाता है। तो उसी तरीके से जैसे कि आदमी के शरीर के लिए हम ये चीज करते हैं, यही चीज जो है ये हमको स्टडी करनी पड़ती है स्ट्रक्चर के लिए। अब इसमें एक बात आपको और बताई गई कि जो हमारे यहाँ पुराने सिस्टम हैं, उनमें जो भारतीय रेल हमारी है, उनके पास में सबसे मजबूत सिस्टम है। वो हमेशा से ये चेक करते हैं आप लोगों ने देखा होगा कि जहां रेलवे ट्रैक होता है वहां पर एक ट्रॉली के ऊपर में 4 आदमी बैठे हुए, जिनको कि जो उनका अफसर होता है उसको परमानेंट वे इंस्पेक्टर बोला जाता है, PWI। उसका काम यह होता है कि हर रेल के जॉइंट पर उसके लोग हथौड़ा लेकर के ठोक ठोक के बजा के आवाज सुनते हैं कि कहीं ढीला तो नहीं है। इसी तरीके से जो रेल के ब्रिज बने हुए होते हैं उनके भी जितने जॉइंट होते हैं उनको ठोक बजा के देखा जाता है। तो ये सिस्टम कुछ रेलवे के पास में बहुत पुराने जमाने से चल रहे हैं। इसी प्रकार से हमारे यहाँ पर एक रोड इंस्पेक्टर का ओहदा होता था पहले किसी जमाने में, जो हमारे रोड बनाने वाले डिपार्टमेंट थे, जिनकी जिम्मेदारी थी कि जितनी भी पुलियां हैं, जितने पुल हैं, जितने सड़क हैं, उनका स्वास्थ्य जाके वो लोग चेक करते थे। वो देखते थे कि कहीं कोई चीज जो है उसमें जो रीइंफोर्समेंट पड़ा है कोई उसमें रस्टिंग तो नहीं हो गई है, कहीं कुछ सरक तो नहीं रहा है, कहीं क्रैक तो नहीं आ गए हैं। और इसका जो रोजनामचा था उसको दर्ज किया जाता था और ये बाकायदा फाइल रखी जाती थी ताकि अगली दफे जब इंस्पेक्शन हो तो अगर उसमें कोई सुधार करने की आवश्यकता है, मजबूती लाने की, तो वो की जाए। तो आपने पहले खंड में ये सुना जो गुप्ता जी ने बोला कि कैसे जो स्ट्रक्चर बनता है उसके डिजाइन करने में चीजों का ध्यान रखा जाए और कैसे उसको बनाया जाए। ठीक है ना? तो ये चीजें हैं। और फिर इसके बाद एक जो सबसे बड़ी बात आप सुनेंगे, अभी हमारे सिन्हा साहब भी बोलेंगे, ये हमारे सबसे वरिष्ठ हाईवे के एक्सपर्ट हैं और देश की जो सर्वोच्च संस्था है, जो मिनिस्ट्री ऑफ रोड ट्रांसपोर्ट के डायरेक्टर जनरल महानिदेशक आप रह चुके हैं, नेशनल हाईवे अथॉरिटी ऑफ इंडिया में रह चुके हैं, तो आप इनसे भी सुनेंगे कि वो नियम किस प्रकार के बनाए जाएं जिससे कि ये सारे सिस्टम जो है उनका प्रयोग किया जाए। अब इसमें एक चीज और है जो कि हमारे हिंदी बोलने वाले जितने हमारे लड़के लड़कियां और बाकी जितने लोग हैं या वैसे जो हमारे काम करने वाले लोग हैं उनके लिए एक और बात बताता हूं। ये एक ऐसा फील्ड है जिसमें कि आपके लिए असीमित संभावनाएं हैं काम सीख करके काम करने की, ये भी मैं आपको बता दूं। और इसमें हमको लेबोरेटरी चलाने से लेकर के, टेस्ट करने से लेकर के, फील्ड में चीजों को देखना और ड्रोन से इंफॉर्मेशन लेना। अब कल आप श्री अजीत कुमार मिश्रा जी को सुनेंगे जो कि डेडिकेटेड फ्रेट कॉरिडोर के चीफ जनरल मैनेजर हैं। वो आपको बताएंगे कि कैसे डेडिकेटेड फ्रेट कॉरिडोर में वो ड्रोन से सर्वे करवा रहे हैं। और वैसे एक बात और आपको मैं बताऊं कि ड्रोन का प्रयोग अब जो है, जो नेशनल हाईवे अथॉरिटी ऑफ इंडिया ने जो अभी अपनी नई नेशनल पॉलिसी बनाई है, वहां पर ये चीज जो है निर्माण के दौरान में सर्वे होती रहे, ये चीज जो है पूरे तरीके से लागू कर दी गई है अब। तो इससे एक और आपके लिए रास्ता निकलता है कि कैसे आप सीखें ड्रोन उड़ाना और ड्रोन की चीजें सीखें, लेबोरेटरी में काम करना, फॉरेंसिक रिकॉर्ड बनाना, ये बहुत सारी चीजें हैं जो कि आपको सीखने को मिलेंगी। तो नक्शल में आपको मैं बता दूं कि क्या क्या बोला गया है ताकि आप समझ करके जाएं और कोशिश करिए कि ये रिकॉर्डेड जो वर्जन पड़ा है यूट्यूब में, इसको धीरे धीरे सुनिए और अंग्रेजी को भी सुन करके उसको समझने की कोशिश करें। एक बात आपको हम बताते हैं, अगर मन लगा करके आप सुनेंगे तो आपको ये सब चीजें समझ में आने लगेंगी, ऐसा कुछ नहीं है। और 2 बार भी सुने, 3 बार भी सुने, इससे शिक्षा ग्रहण करिए, ये आपको सीखने के लिए एक मौका बड़ा अच्छा मिल रहा है। तो चंदन बाबू,
हाँ,
एक और आपको अच्छी खबर बता देता हूँ।
हाँ, हाँ,
हमारा जो वैलिडिक्टरी फंक्शन हो रहा है
या
उसमें जो अभी हमारे डायरेक्टर जनरल साहब हैं MORTH
पांडे साहब, हाँ,
जी, वो आ रहे हैं हमारे साथ में और उनका कंफर्मेशन अभी अभी आया है। तो मेरा सबसे निवेदन यही है कि आप सब लोग तीनों दिन मन लगा करके सुनिए। हर रोज हम लोगों ने काफी अच्छे लोगों को बुलाया है जो कि आपको बहुत कुछ ज्ञान देंगे। और इस सारे वार्तालाप के बाद में हम लोग एक खाका खींचेंगे कि हमें क्या क्या करना है, कहाँ कहाँ पे हमारी कमियां हैं जिनको कि हम पूरा करें। तो मेरी आशा है कि आप लोगों को मेरी बात समझ में आई है और फिर भी अगर न कुछ समझ में आया हो तो आप प्रश्न पूछिए, हम लोग उसको उत्तर देंगे और हिंदी में भी देंगे, निश्चिंत रहिए। हिंदी में भी देंगे, तमिल में भी देंगे, क्योंकि हमारे कई लोग इसमें तमिलनाडु से भी ज्वाइन किए हुए हैं। तो भाषा की चिंता मत करिए, भाषा हम लोग सब भाषाएं बोलते हैं, ये सब हमारी अपनी भाषा है। ठीक है, लीजिए चंदन बाबू आगे बढ़ाइए।
धन्यवाद डॉक्टर स्वरूप फॉर बिल्कुल आपने जिस तरह से जैसे रसगुल्ला खिला दिया जैसे, हाँ, जो गुप्ता साहब ने जो बताया है, आपने पूरा उसका एकदम समरी दे करके यू हैव मेड ए वेरी नाइस, थैंक यू वेरी मच, एंड इट इज always it will add, it is going to add the value of this, and इसमें ये भी है क्या डे आफ्टर टुमारो जो पांडे साहब रहेंगे डायरेक्टर जनरल रोड, and also in the Ministry of Road and Transport, Highway, और वो भी स्पेशल सेक्रेटरी है, he is also special secretary to the ministry. तो ये हमारे लिए एक बहुत अच्छी encouraging वर्ड बात है, तो हम इसमें बहुत we are very happy to have this information. Now Gupta Sahab, please be with us, and if in between some queries are there, but those are all on just small query that क्या ये पूछ रहे हैं, one of the चंद्रशेखर जी पूछ रहे हैं क्या ये जो आपने लास्ट मोमेंट में जो रिपेयरिंग और जैसे प्री स्ट्रेसिंग का एफआरपी वगैरह जो करके दिखाया है, उसमें क्या लाइफ ऑफ द स्ट्रक्चर is sustained or life of the structure is increased, ये थोड़ा सा एक जानकारी उनको चार्ट बॉक्स में चंद्रशेखर जी ने पूछा है, वो तो जरूर, अदरवाइज उसको अगर इंश्योर नहीं करेंगे तो वो ब्रीज फंक्शन कैसे करेगा, ये है ना?
यस नहीं सर, आपकी बात बिल्कुल ठीक है और क्वेश्चन डेफिनेटली वैलिड है और ये लोगों ने पहले भी पूछा हुआ है. लाइफ उसकी वही है जो स्ट्रक्चर की है, बिकॉज उसके अंदर जो अपॉक्सी है वो भी इट हैज़ अ फुल लाइफ 100 ईयर्स जो होता है हमारा डिज़ाइन लाइफ, और जो एफआरपी है फाइबर रिइंफोर्स पॉलीमर वो भी इनर्ट मटेरियल है, दैट आल्सो हैज़ अ फुल लाइफ, एनी नंबर ऑफ ईयर, देयर इज नो प्रॉब्लम. तो लाइफ इज एब्सोल्युटली नॉट एन इशू. और अगर हम प्री स्ट्रेसिंग कर रहे हैं, एक्सटर्नल प्री स्ट्रेसिंग सपोजिंग, तो प्री स्ट्रेसिंग हैज़ टू बी केप्ट इन सीमेंट ग्राउट. सीमेंट ग्राउट का पीएच वैल्यू होता है नियरली 13 to 14, विच इज़ अ वेरी हाई पीएच वैल्यू, देयरफॉर फुल्ली अल्कनाइन एनवायरनमेंट. बस उस ग्राउट में हॉलीडेज नहीं होना चाहिए, क्वालिटी कंट्रोल शुड बी गुड, then this grout will ride, I mean the pre-stressing will last as much as a bridge. In fact जिस ब्रिज का मैंने फोटो दिखाया था थाना क्रीक जहाँ पे के हुआ था, उसका हिस्ट्री ये है, डॉक्टर हर्षवर्धन इज ऑल्सो विद अस, ही विल नो मच बेटर. फॉर 6 to 7 years कंस्ट्रक्शन ही नहीं हो पाया, बीच में रुक गया. तो एज ए रिजल्ट जो प्री-स्ट्रेसिंग केबल्स थी, दे वर नॉट ग्राउटेड एंड दे रिमेन्ड बेयर इन द क्रीक्स सी. सो वो कोरोड होती गई और फिर फाइनली दे बिकम वेरी बैड. So I think that should be a short enough answer because I'm sure the second speaker must.
Yeah. In case we get some more queries, we'll surely connect it with you and we may seek your
certainly
reply on that so that we can communicate with our.
My pleasure.
Okay. Thank you very much.
Thank you.
Okay, friends. Now we are going to call Mr. N.K. Sinha, who has devoted his life that in this bridge inspection and documentation process, especially, and developed many codes and guidelines. In fact, his topic is itself bridge inspection and documentation process, codes and guideline. So he was Director General in MORTH, and also he is presently President of ICT Limited, and also of course he is a BSc Engineering 1962. In fact, I was not born by the time, but from Patna University. Sir, most welcome, sharing your august experience for more than 60, almost going to be 60 years. And also in road sector, in fact, he is working since 1965, and then he joined, in fact, the Ministry of Road Transport and Highways at that time itself, and has held various positions therein. And he was member technical in National Highway Authority of India, and he was also in charge of road construction project in Kenya for 5 years, and he has also held the position of Chairman, International Road Federation, India chapter, Treasurer, Indian Road Congress, and Chairman, ING of Indian Association of BSc. Okay. He has all-round experience of 56 years and construction, operation and maintenance and financing of road projects, including contract management and arbitration. So we are going to have you, sir, and of course, you have retired long back, joined engineering branch before I born, but you have not retired from our perspective. So please. सर कुछ लोगों ने बोल रहा है क्या हिंदी में बताएं, कुछ लोगों ने बोल रहा है नहीं हिंदी नहीं इंग्लिश में बताइए, तो सर आप जैसे समझे ऐसे बताएं।
बड़े भाई थोड़ा सा मतलब मिला जुला करके चलाइए, सब लोगों को समझ में आना चाहिए। अभी मैं देख रहा हूँ एक आध चैट आई है जिसमें कि उन्होंने कहा है कि साहब इंग्लिश में ही चलाइए खाली, तो मिला जुला के चलाइए, सब लोग मिलजुल करके इसको समझेंगे। चलिए।
ये कहा मेरा प्रेजेंटेशन
उसमें शेयर
माय प्रेजेंटेशन CIDC से प्रेजेंटेशन करेगा।
CIDC से
Lakshmi, are you able to hear me?
Yes, sir. We are uploading, sir.
Yeah.
Upload करो, upload करो।
Okay. Yeah.
Yeah. Thank you, Mr. Ghosh, and good evening to every delegates, all my colleagues. I want to give you the background of bridge inspection. Basically, this started in very early 1970s. We had made a formal kind of documentation for bridge inspection in Ministry of Road Transport and Highways. And till now, we have not been able to achieve much. And that is my main topic in this one. Next, please. Next. This is the Indian road network, which is 56 lakh kilometers, different types of roads, whereas national highways is only about 1.01 lakh kilometer, which is about 2% of the whole network. So you can see the major part of the road network is on other highways other than national highways. Yeah. Next, please. Next. Now, this detail has been obtained from the data received by the national highways. You know, they had engaged some consultant for carrying out the inspection and inventory of bridges, which has been discontinued now for last 2-3 years. So from there, the number of bridges on structures on national highways was 1,72,517. And these are the two types. Structures means culverts. That is 1,34,000 was culverts and about 38,000 bridges. Special bridges, extra long bridges were also have also been there, 1,835. And they found that at least 5% of these structures and bridges are in distress. Means there are some, they require certain repairs. So this is how the figures came. Next. Taking that into account, taking this figure, because we do not have the figure for the whole network. So I have just worked out on the average spacing of the bridges, same as national highways. We have 95 lakh structures. You can imagine, of which 21 lakh is number of bridges all over the country. Now, here we have the that distressed bridges, I said 1,05,000, which is very, very wrong, because 5% bridges were affected, were under distress, because of the maintenance level in national highways is quite high comparatively. And whereas on the other roads, it is much, much below. So that figure must be around 10 to 15%. So if you say 15% of these bridges or these structures are in distress, then huge amount of work is involved, required. Thank you. Next. Next, please. Lakshmi, next.
सर इंटरव्यूड में हिंदी में थोड़ा बोल दीजिए ताकि लोग पिकअप करते रहेंगे।
अच्छा, हाँ।
जो ट्रांसफर टाइम हो उसमें।
ठीक है। इसको जरा बैक करिए 1 मिनट, या बैक, लक्ष्मी बैक कर लीजिए। हाँ, एक और बैक कर लीजिए। ये हमारे कंट्री का मेन रोड नेटवर्क का लेंथ है 56 लाख किलोमीटर। उसमें 1 लाख किलोमीटर जो है नेशनल हाईवे है, विच इज 2%। और नेशनल हाईवेज पर ये इसका दिया हुआ ये जो फिगर्स जो दिए हुए हैं, ये ब्रिजेज और स्ट्रक्चर्स का, ब्रिज और कल्वर्ट्स का टोटल कितना है, और उसमें कितने ब्रिजेज में डिस्ट्रेस थे, माने जिसमें कि कुछ रिपेयर वगैरह की जरूरत है, ये यहाँ दिया हुआ है। और ये फिगर से इससे हम निकाल रहे हैं, चूंकि अदर नेटवर्क का, पूरा नेटवर्क का हमें डिटेल मालूम नहीं है ब्रिजेज का, इसलिए हमने निकाला है कि पूरे अगर उसी रेट पर, जैसे एवरी 2.6 किलोमीटर पर ब्रिज आता है, इसके हिसाब से, उस हिसाब से अगर निकालते हैं तो कितना होता है, वही निकाला है। नेक्स्ट करिए लक्ष्मी, नेक्स्ट लक्ष्मी, नेक्स्ट। हाँ, या उस हिसाब से निकाला है, तो वो पूरे नेटवर्क पे 95 लाख ब्रिजेज एंड कल्वर्ट्स होते हैं। आप इमेजिन करें कि पूरे कंट्री में 95 लाख, और उसमें ब्रिजेज का लेंथ, ब्रिजेज का नंबर है 21 लाख, तो उसमें जो डिस्ट्रेस है वो अराउंड 10 to 15% होगा, बिकॉज वो सारे नेटवर्क जो है इतना अच्छी तरह से उसका देखभाल नहीं करते हैं जितना मेंटेनेंस हम करते हैं नेशनल हाईवेज पर। उसमें खर्च भी ज़्यादा करते हैं, कुछ नया भी बहुत बनाया है, तो उसके वजह से वहाँ पे कम है। बट अदरवाइज अगर जनरल नेटवर्क का करें तो 15% मिनिमम हो जाएगा। 15%, 21 इसका हो जाएगा 15 लाख का 15% हो जाएगा 1.5 लाख, है ना। चलिए नेक्स्ट। हाँ, अब ये जो है इसके बेसिस पे हम ये कर रहे हैं कि हेल्थ असेसमेंट के लिए क्या क्या करते हैं। द फर्स्ट थिंग इज इन्वेंट्री, जो स्वरूप साहब ने पहले ही कहा था कि पहले हमें तो पता भी नहीं है कि कितने ब्रिजेज है, कहाँ है। फैक्ट इज कि ये जो है सो मिनिस्ट्री ने जो एक बार अभी जो दिया था, कंसल्टेंट को अपॉइंट किया था, उससे उन्होंने पूरे नेटवर्क पे ब्रिजेज का पता लगाया, कहाँ कहाँ ब्रिजेज है, कहाँ कल्वर्ट्स है, एक उसका पूरा एक इन्वेंटराइजेशन हो गया फर्स्ट, देन देयर आफ्टर द इंस्पेक्शन विल स्टार्ट। सो फर्स्ट इन्वेंट्री में मोटा मोटा चीज, जैसे क्या, कौन सा स्ट्रक्चर है, क्या उसका मेजर स्पैन है वगैरह, वो सब डिटेलिंग देख लिया, क्या स्ट्रक्चर बना हुआ है, ऑल दोज थिंग्स। तब उसके बाद हम आते हैं इंस्पेक्शन पर। अब इंस्पेक्शन का हम बाद में बताएंगे उसका शेड्यूल क्या रहता है, बट इंस्पेक्शन करना जरूरी है। क्यों जरूरी है? इंस्पेक्शन इसलिए है कि ये जो है, जैसा स्वरूप साहब ने बताया कि कोई एक चीज जो बना वो हमेशा डिटोरिएट करेगा, नेक्स्ट डे से डिटोरिएशन शुरू हो जाता है। तो अब द फर्स्ट इंस्पेक्शन जो आप 1 साल के बाद या 6 महीने के बाद जो करते हैं कंस्ट्रक्शन के बाद, दैट रिकॉर्ड्स वहां से शुरू हुआ। अगर कोई कंस्ट्रक्शन डिफेक्ट्स हो गए हैं या कोई और अदर डिफेक्ट्स आ गए हैं उसके बीच में, वो सारा का सारा रिकॉर्ड चलना चाहिए। और ये इसीलिए इंस्पेक्शन रिकॉर्ड शुरू हो जाता है जस्ट आफ्टर द कंस्ट्रक्शन कंप्लीशन ऑफ 1 ईयर के बाद से ये इंस्पेक्शन शुरू हो जाता है। देन उसी के हिसाब से फिर हम उसका रिपेयर प्लान बनाते हैं। अगर कोई डिस्ट्रेस में है तो उसको जो है हम वी विल प्रिपेयर द रिपेयर प्लान एंड रिपेयर प्लान बना करके और उसका इम्प्लीमेंट करते। इन नटशेल दिस इज द हेल्थ असेसमेंट ऑफ ब्रिजेज का यही एक इशू है। फर्स्ट इन्वेंटराइजेशन, नेक्स्ट इंस्पेक्शन ऑफ ब्रिजेज। इंस्पेक्शन ऑफ ब्रिजेज का हम बाद में दिया है कि कैसे क्या करना है उसके लिए। एंड देन प्रिपेयर द रिपेयर प्लान बेस्ड ऑन द इंस्पेक्शन evaluation or inspection reports. Wherever required, you prepare repair plan. It is not necessary that for each bridge there will be a repair plan. No. Inspection say wherever you find there is some kind of distress to uh, to stop that distress or to overcome that distress, you prepare the repair plan. जो अभी बता रहे थे मिस्टर गुप्ता भी बता रहे थे epoxy and other things से, तो रिपेयर प्लान बनाते हैं। देन दैट हैज टू बी इम्प्लीमेंटेड, तभी वो इंस्पेक्शन का पूरा का वैल्यू है। अदरवाइज हेल्थ असेसमेंट खाली हमने जान लिया कि ये बीमारी है, दिस इज द सिकनेस, बट इफ यू डोंट टेक एनी मेडिसिन देन देयर इज नो गुड, इट्स नो यूजफुल। नेक्स्ट करिए, नेक्स्ट। अब इसमें आप मैंने ये बताया, अब आई एम लिमिटिंग हियर टू इंस्पेक्शन ओनली, बाकी दूसरी बार करेंगे। गाइडलाइंस, इसका इंस्पेक्शन का हमारा गाइडलाइंस है, रूटीन इंस्पेक्शन 2 times a year होता है, once before monsoon, another after monsoon. This is a kind of typical Indian scenario में यही हम लोगों का कर रहा है कि routine inspection is carried out once before monsoon and once after monsoon. So this is something which we need to do, we need to carry out. And I have given you the background of number of bridges, so उसको हिसाब से आप देखिए, ये routine inspection करना है। Then detailed inspection has to be carried out once in 2 years. This is a very detailed one, means कि every part of the bridge has to be seen as much as possible. Foundation up, you can't see foundation, but at least you can see the upper substructure and superstructure and all other parts. So those things should be seen in detail, very critically. If there is any crack or if there is any spalling, all those things to be recorded. So this is called detailed inspection, once in 2 years, each structure. And special inspection as required. Supposing sometimes some failure occurs, some accident has occurred, then you carry out special inspection. Then you don't wait for 2 years to happen. So immediately you carry out the special inspection, and then you find out what are the repair mechanisms. So this is the kind of guidelines provided for inspection. And Mr. Swarup also mentioned about the requirement of manpower, which I am taking average 2 persons 2 days per bridge on structure. I see what I have done here. I have modified it, because now you are using drone also, now you are using other mechanism also, instrumentation also. So all these things combined together, but you cannot substitute manpower, is required, always required, because most of the bridges or culverts you require only physical inspection. So I have put a figure of 2 persons for 2 days, each structure and inspection, bridge and structure, and there are 95 lakhs. So imagine, bridges to be inspected per year is 47 lakhs 50,000. And so number of persons here required is 95,000. 95,000 if required है only for inspection. This is only for inspection, which is skilled, semi-skilled and specialist. See, ये सब मिला करके है. So semi-skilled means कि there should be bridge inspector. He should be fully trained how to inspect a bridge, or how to record these deficiencies, or how to record any event. Semi-skilled, helping them and especially so this is there is a kind of we have got a code also for health for the inspectors, bridge inspectors manual. So like this, skilled means ki bridge inspector, he has to be bridge inspector, and that is that could be either diploma holders or even the I mean 10th or 12th pass, having some experience, some training. They can also be engaged as health inspector, bridge inspector. So this is something which we have to detail uh, the composition of this one before we start the bridge inspection. Next, please. ये हमारा ये कोड्स है, कोड्स फॉर हेल्थ असेसमेंट ऑफ ब्रिजेज. हमारे बहुत से कोड्स बनाए हैं. So for roads we are actually on the side of codes. We are almost complete, which can we there are some modifications always going on to make it update, but it is quite genuine. I mean, complete, almost complete. Say, the first one was 1978. I mentioned to you SP 18 1978, which was Manual for Highway Bridge Maintenance Inspection. This is how it was designed, and that is where we decided to have what are the frequencies of inspection. SP 35 1990, guidelines for inspection or maintenance of bridges. This this was this has been revised also. So this actually gave you how do you inspect, and what are the what are the norms, what are the sections, how to inspect bridges, and it also gives a table for your inventory of bridges. So this is a IRC 35, SP 35 is one code. SP 37, load carrying capacity of bridges. See, I mean, as you know that there are some old bridges, new and very old bridges, and then new bridges. So it is not necessary that all old bridges should be demolished and made into new bridges with new loadings. So what we do? We keep the old bridges also wherever we see the traffic, according to traffic, it is permitted. So that way, we have to find out the load carrying capacity of bridges. So that is what this method gives. This IRC SP 37 provides you the methodology how to determine the load carrying capacity, say class 12 bridges, class 18 bridges, and if it is modern bridges, so class 70R. 70R is the current loading for this one bridges. So that is all, say class A, class AA, like that, So you have to have a correct loading determined, and if you find the load carried on that bridge, on that road section, is more than the load carrying capacity of the bridge, on that section, that has to be replaced. This is the idea. SP 40, guidelines on techniques for strengthening and rehabilitation of bridges. This is where the uh, I mentioned to you about repair and rehabilitation. So once you evaluate the inspection notes, inspection reports, and find out what are the drawbacks, what are the uh, deficiencies, then according to that we can prepare the rehabilitation or repair and rehabilitation plan using these guidelines. So this is one good thing. एक पीछे रखिए लास्ट जो है उसमें लक्ष्मी पीछे वाला है. हाँ,
Yes, sir.
SP 52 Bridge Inspectors Reference Manual. This is very important, which is what I had mentioned to you. It gives you how the bridge inspector should be trained. What, they must have differentiation of measuring the cracks also, crack width, something like that. And then plot it, a crack in the web of a girder, a crack in the bottom of the flange, or a crack at the top of the deck slab, all have different meanings. It's not so important, so simple that crack, it is cracked. No, डिफरेंट प्लेसेस पे उसका मीनिंग डिफरेंट है. तो ये सारे कुछ इसमें ब्रिज इंस्पेक्टर्स रेफरेंस मैनुअल में दिखाया गया कि आपको you have to prepare a sketch showing where it is, and exactly you have to draw it so that you can make a good reference. The bridge inspectors manual का एक important चीज है. See, when you have any inspector has done this inspection, next year another inspector will go and he will see the same crack. How will he determine whether the cracks are same or it has increased or it has decreased? So that is the idea of training. So bridge inspectors, once they are trained in the same manner, so they know how to record the thickness, how to record the recordings, where it is located and how it is located, what is the direction of the crack, all those things, even all other deficiencies also. So these are some things which only will come by training. It is not that anybody else, to me, I will say that nah, this bridge is very, very weak, or very serious cracks are there. Somebody will say, no, these are not serious. So how to determine that serious or not serious? So this is how the reference guidelines are given there, and they will say this is the way you need to inspect. And once you inspect all those deficiencies, record it. That is the kind of reference here. And I think there are some videos also available. So this is the training of bridge inspectors is one of the most important thing required. Next, please. बताइए. Next, लक्ष्मी.
यस सर.
या ठीक. नेक्स्ट है इसमें ये जो जैसे कहा आपने, हमने कहा रिपेयर प्लान्स बनाने के लिए guidelines for corrosion prevention, monitoring, remedial measures for concrete bridge structures. Now, this is something which corrosion has become a big problem for concrete bridge structures, and even coastal area में तो corrosion है ही. I mean, that is very, very much prevalent. Yet, even doing this repair of this Yamuna Bridge in Delhi, we had this problem of corrosion. So that is where this corrosion prevention has got to be done very seriously, and they are giving some guidelines and methods, measures, how to do it, how to carry out these corrosion protection on bridge structures. We have also got steel bridges. So for that also these two guidelines are there. SP 75 and SP 74 guidelines for retrofitting steel bridges by pre-stressing. I mean, if there are some fractures, then they actually pre-stress it. पीछे हाँ. और then अगर कोई repair rehabilitation of steel bridges का भी दिया हुआ है details. There is another document which is a very important one, and this is an approach document for assessment of remaining life of concrete bridges. See, if you prepare a repair plan, then one of the question is, what is the remaining life of this concrete bridge? Supposing the bridge itself is going to last another 10 years or another 5 years, then why spend so much for repairing it now? So that approach, that has to be also certified that yes, by doing this repair, the bridge is going to last all minimum 30 years or 40 years, something like that. So this is where this is a document on the basis of which you can assess what is the remaining life of a concrete bridge. So this is a very good document. In fact, this has been done with the help of Dr. Subbarao, uh, father of our Mr. Harshvardhan Subbarao. So this is a very important document. We regard that very much. Next. Uh, I'm giving briefly. I mean, there were presentation by Mr. Binay Gupta. He gave you so many things that how uh, how the distresses can occur and how it happened and how it was repaired. So I'm just giving you reasons for distress. One is overloading. This is one very common kind of reasons for distress condition. So many people will ask that today we have made bridges, and after 1 year or after 2 years, why should it have this distress condition? So this is what I have just tried to note it. Overloading. Supposing the bridge is more loaded with more load than the design load. This is one. Then under design or certain loadings ignored. Supposing during design time we had forgot some loading. We had we forgot that there is some snow load also, or there are some uh, rolling stone is coming from the hills, side hills, and coming to the bridge. So like this we have ignored certain things. Some design criteria have been missed, and because of that, that may create distress condition. And errors in construction is a very important issue, because now, I mean, we say that about 70 to 80%, 80% at least, is distress is because of errors in construction. Very common. Supposing you have a clear cover. Now you just reduce it clear cover by quarter inch, and then see the stresses. Anything, any say placement of uh, uh, reinforcements are there. I mean, Mr. Gupta mentioned that one the bearings were turned 90 degrees, something like that. So errors in construction can be anything. I have seen during inspection in Gujarat, that one bridge, you see, we fix up some nuts in the bearing assembly. To fix the bearing, we fix up nuts before placing of girders. The bridge was completed, but those nuts were not removed for next 10 years. When we were inspecting, we saw those nuts were there. Then we released it. So that might have caused lot of defects, I mean, cracks. Maybe there are some cracks also. So those are some things which you cannot see. You can only have that kind of thing unless you inspect. You cannot find it. So errors in construction is another cause for distress condition, and variety of causes could be there: alignment, curvature, then depth. So many things. Inadequate detailing. This is also there. One very important, one very common thing which all engineers know: if you put the laps at one place, then you had it. There will be cracks. There will be the failure. So though I mean, the courts prescribe that there should be limit on the laps at one place, at one section. But at many places you are forced, or somehow people ignore that limit. So they put all the laps at one place, and that is where the failure can occur. So that those things are not that key, they don't happen, they happen, they do happen. And this is how we call inadequate detailing. Then we have got differential settlement of foundations. This is also another. And somehow I don't know whether I have given all, but at least uh, I've tried to do list out as much as possible. So foundations differential settlement is very common. I would say that if you have not checked, that is why we have prescribed that before founding you have to have the you should take the SBC and the bearing capacity before founding. So that is where the differential settlement of foundation should be limited. Otherwise, the you won't get that. Uh, uh, I mean, if you limit that settlement to 12 millimeter, probably differential settlement of foundation can be restricted. But that is something which you need to design methods. It will come in design methods. Sulfate attack on cement in concrete. There are some areas uh, where the air is acidic, or the water is acidic, and you get sulfate attack on cement concrete. And it actually it bites into the concrete, and so the concrete is gone, disintegrated. So that is how this makes the distress condition. Alkali aggregate reaction, this is something which we need to check on all aggregates, that whether it is reactive to alkaline or not. And usually we forget, usually we take it that there is no aggregate reaction, but this does happen. And once it happens, then really the concrete is disintegrated. Corrosion rusting of steel component, this is another issue which I had just mentioned, that it can happen anywhere. As I told you, that if when we can have in Delhi that this bridge, so it can have anywhere. This is Delhi is very far from the coast, but yet it happened because of the atmospheric corrosion there. So this could happen anywhere, and I mean, how you measure it, that is a different issue that we will see later. But this is we have these are reasons for distress. And weathering. Weathering means, of course, the humid weather, and all too hot. Say, I mean, temperature effect also. Sometimes you have some very extreme weather condition. So those are distress conditions, reasons for distress condition. Next. Next. Now, for all these things, systematic changes are required for avoiding distress in bridges. This is how I have summed up, and this is I will deal later on each of them. But just a brief. You have to set up an organization. What I have come from my experience, that without setting up a separate organization for inspection, you cannot deal with it. It's a very difficult to add it to the existing organization, a kind of inspection unit. No, it is not possible. See, what happens that you it's a continuous work. I'll just narrate here. Creation of inspection team also has to be created. You have to have the evaluation of inspection reports and preparation of repair plans. Now, for evaluation of inspection reports, you have to have all the as-built drawings. Particularly, all as-built drawings have to be kept there. So every 2 years you require that as-built drawing for evaluation of another inspection report. So like this, those are the places where it has to be uh, I mean, you can say uh, put in a permanent establishment kind of thing. So then prepare repair plans. implementation of repair and rehabilitation plans, training program, and all these require necessary budget. My take is that we should have a good institution which should have we should assemble all these things. They will also have uh, the support of specialists. They should also have a support of instrumentation organization. So all these things are required, and then only it can be self-sufficient. I have seen comparatively it mentioned that railways have a good system. Yes, by 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 virtue of their system, they are able to produce this good results. I have seen in US there is a separate organization for inspection of bridge. They are not doing anything. They are it is of the level of this supported by head is a chief engineer level somebody, director or chief engineer, and this is only doing in each state. State there is a department called only inspection of bridges. So that is how it is there. But here we are not having that kind of system. That is why I I will suggest that there should be some proposal for setting up of a particular institution responsible for setting up of this inspection. Because once you do it today, just like today means after 2 years, its date is next 2 years. There is a date. So automatically the appointment is fixed for inspection. So that kind of system should come up. Next. I think it is closed now. Yeah, thank you. So in nutshell, I have given you why we need inspection of bridges and how we can take care of this. The present system, when it is being done by PWD or ministry, whatever, it is not adequate because the people who are doing inspection are not qualified to do it. That's my summary. In summary, I can say that. Thank you very much. Thanks for the listening me.
धन्यवाद सर।
धन्यवाद जी।
आपने बिल्कुल जो you have given all the manuals which we were discussing even yesterday also, that करीब 11-12 कोड SP स्पेशल पब्लिकेशन IRC का है, और there almost even some revisions are going on, and you have shared also since 1970s you have been looking into this inspection health assessment part. Now 1970 has now turned to now 51st year.
Yeah.
And many failures are happening day by day during monsoon, and many things are happening. And you also highlighted about that how many manpower is required, which is very much required, even though we can have extensive satellite survey, LiDAR survey, instrumenter survey, so many things.
Yeah.
Still,
करेक्ट।
ये इसमें तो चाहिए मैन पावर जो आपने एकदम कितना रोड्स है, कितना परसेंटेज है, शुरू के 3-4 स्लाइड में आपने दिखाया है। क्या जिम्मेदारी जो कोविड के सामने जो कोविड है, अनएम्प्लॉयमेंट है, हाई कॉस्ट ऑफ इंफ्रास्ट्रक्चर एंड एवरीथिंग, सीमेंट एंड स्टील इज देयर, बट स्टिल वी नीड मैन पावर। तो ये मैन पावर का आप पूरा एकदम इंजीनियरिंग उसमें तो हमें कैलकुलेशन पूरा एकदम हिसाब करके, जैसे हाईवे में क्वालिटी अच्छा होता है उसमें आपने 5% बोला, क्या 5% भी लें तो फिर भी 1 लाख से ऊपर है, फिर उसका कई गुना ज्यादा जो अदर हाईवेज में है तो उसका तो 5% लेके जाएगा। What you have wanted to know, that maybe 10-15% भी हो सकता है। So there is a huge number of things which you have said that it is not less than 1 crore, around 1 crore or something। अब 1 करोड़ में आपने मैन पावर भी हिसाब कर दिया है, तो इसमें जो जितने पार्टिसिपेंट्स हैं इनके लिए ये संदेश है, क्या प्लीज गेट अप एंड गेट रेडी टू गेट दिस काइंड ऑफ व्हेन 10-11 मैनुअल ऑलरेडी है, और 2019 में 1978 से बना करके अभी 2019 में एक रिवीजन हुआ है, कुछ रिवीजन और भी चल रहा है, एंड कोरोशन एस्पेक्ट, रिहेबिलिटेशन, रेट्रोफिटिंग, स्टील ब्रिजेस, all these things are there from 1978 to 2019 जो लास्ट रिवीजन है, कुछ और भी चल रहा है. सो जो मैन पावर का जो आपने हिसाब दिया है, मतलब आपके जो उसमें ये मैन पावर को हमें मास स्केल पे जो तैयार करना है, तैयार करना मतलब इसके हिसाब से जहाँ पे कैसे इंस्पेक्शन करना है, इंस्पेक्शन का जो मेथोडोलॉजी दिया हुआ है एंड उसका रिवीजन भी हो रहा है, न्यू थिंग्स आर आल्सो बीइंग एडेड. तो आपका जो इसमें स्पेशली आपका योर दिस, आई वुड नॉट से इट इज अ लेक्चर, रादर आपका जो अनुभव जो आपने जो इसमें सरल तरीके से जो प्रेजेंट किया है, क्या व्हाट इज एट स्टेक एंड व्हाट वी आर गोइंग टू लुक फॉरवर्ड in the breeze inspection and health assessment.
ये घोष साहब, एक जो प्रोफेसर घोष, एक मेरा था कहना कि 95,000 जो हमने बनाया है, एस्टिमेट जो किया है, दिस इज ए कांस्टेंट फिगर, दिस इज नॉट 1 ईयर. ये एवरी ईयर ये कांस्टेंटली रहेगा और ये बढ़ेगा, क्योंकि अगर नंबर ऑफ स्ट्रक्चर्स बढ़ेंगे, नंबर ऑफ ब्रिजेज बढ़े, अभी हमारा जो है इंफ्रास्ट्रक्चर बढ़ रहा है, तो नंबर इंफ्रास्ट्रक्चर बढ़ेगा तो हमारा ब्रिजेज भी बढ़ेगा, तो वो बढ़ेगा तो फिर वो इंस्पेक्शन भी बढ़ेगा. बट माय पॉइंट इज समवेयर या तो स्टेट ही अपने यहाँ एक बनाए, एक ब्रिज इंस्पेक्शन का एक पूरा एक महकमा बनाए, या फिर एक जो है, सो मैं हमारा जो विजन जो था, मैंने आई कैन इवन टुडे से कि CIDC has got around 20,000 training engineers. उसके साथ जो है, उसके पास जो है एक बहुत अच्छा ऑफिस है, तो यू कैन सेलेक्ट ऑफिस एंड इट विल रिमेन एज डिपॉजिटरी ऑफ नॉलेज, जैसे कह सकते हो, डिपॉजिटरी ऑफ इंस्पेक्शन रिपोर्ट्स. दैट इज माय suggestion. I mean, that I will make it on the last day, but I just at the site of this is what I was saying, and all the people will be attached, all the consultants, contractors. There are many issues in this one, not only the inspection. The जो है इसमें सारे, see, and it will have to be taken now into what I propose, that let us see कि से एक बार पहले अगर ड्रोन से अगर कर लिया मेजर ब्रिजेज का, उसके बाद डिटेल्ड इंस्पेक्शन के लिए आपको जाना है, जहां आपने देखा कि कहीं कोई डिस्ट्रेस है, देन यू हैव टू गो. यू कांट डू इट विथ ड्रोन से तो एक आ जाएगा, फोटोज आ जाएंगे, बट यू हैव टू गो देयर एंड सी पर्सनली. मैं आई मीन जा करके कोई मोबाइल ब्रिज इंस्पेक्शन यूनिट या कुछ लगा करके वो करना पड़ेगा. बट तो उसके लिए कुछ ज्यादा ही बन जाएंगे कंसल्टेंट्स का, वो स्पेशलिस्ट जो कंसल्टेंट्स होंगे, फिर उसके लिए चाहिए. तो देयर आर इश्यूज, देयर आर मेनी मोर इश्यूज कमिंग देयर.
यस, तो इसमें तो मुझे लगता है जो जैसे आपने शुरू में भी उल्लेख किया है, some consultant government has made, and they made some data, but now it is not being done routinely. So things are getting piled up or added up.
That is where my concern is, that I had been trying, but at least I must give credit to the present DG, that he got it implemented, but only for 3 or 4 years, but thereafter it has been discontinued again.
Okay.
So that is my issue, that I tried various levels, but I could not succeed in my time. But it has been done now. It's a very good effort. It was being done in IAAC. They had established a center. So for national highways they were doing it, but thereafter it has been discontinued, which is to me it is unfortunate for bridges. I don't know how others feel, but I feel that was something very good system which was being done for national highways. And the same system should be evolved for all other
culverts and bridges and
all other
structures.
road sections.
Yeah.
That is the crux of the issue. This whatever I presented.
So I think this is a great message that what could not be done doesn't mean that it ends there, but our young generation or ourselves, let us restart these things using our mobile phone and application, mobile app वगैरह लगा करके Google Earth में इसको जियो टैगिंग करके कम से कम उसका पॉइंट वाइज आइडेंटिफाई तो कर सकते हैं और Google Earth में भी तो प्रेजेंट कर सकते हैं तो और इसमें कोई पैसा इन्वेस्टमेंट कुछ नहीं चाहिए तो हम चाहेंगे इस प्रोग्राम के दौरान ऐसा एक्सरसाइज जो यहाँ पे पार्टिसिपेंट स्पेशली यंग जनरेशन के पार्टिसिपेंट्स है उनके those participants will be taking part. We want their chat box में उनका इच्छा प्रकाश हम चाहते हैं please write it and then we'll coordinate it from CIDC and IDM side to locate all those places using old data as well as adding new data and location using mobile app. Mobile app आजकल घंटे में बनता है, so that we can see in a Google Earth map which is freely available. और लोकल मैप क्या GIS मैप में इसको दिखा सकते हैं, कम से कम लोकेशन पता है, जो नंबर आपने बताया है, जो इतने ब्रिजेस है, एटलीस्ट लेट अस गेट दिस स्टैटिस्टिक्स in a mobile or in a digital platform. Then, as you said very rightly, that the code or IRC जो guidelines है और इसके बेसिस पे हम इसमें ट्रेनिंग देना शुरू करें. And many other professional organizations are there also, क्योंकि इतने लोगों को एक साथ ट्रेनिंग देना, even though it is being started now online, but physical inspection जो है उसमें हम जो उनमें से we will see that which are critical one. तो उसमें हम बोलते हैं rapid visual screening stage 1, stage 2, stage 3 करके फिर हम एक डेटा स्ट्रक्चर बना सकते हैं, फिर हम उसमें काम कर सकते हैं. Okay. इसमें
Thank you, Professor.
Okay. So, okay. I think आपने ऐसा दिया है उसमें कोई किसी का क्वेश्चन पूछने का जरूरत ही नहीं है.
Can I add one point, Professor Chandan Ghosh? This is Dr. Harsha. Can I add one point to the very important discussion?
Yeah,
the problem is, sir, we have a Indian bridge management system that was put in place some years ago.
Okay.
In its percept, it was a good thought, but in its actualization, it has failed on many fronts. Those need to be addressed to make it useful.
Okay.
Number one, it has stopped at a level of inventory alone and a level of prioritization to a very rudimentary degree.
Okay.
I wouldn't say it is sufficient because it doesn't handle things like deterioration modeling. It doesn't handle things like transition matrix. It doesn't handle the basic degradation and the time-based issues of intervention that are required from a bridge management system. There are different modules in a bridge management system. Our Indian bridge management system is restricted only to the national highway, which you saw is such a small amount of actual roads and therefore bridges. And it is restricted only to the inventorization. It doesn't have multi-criteria decision making. It doesn't have the deterioration modeling. It doesn't have what we call the Markov deterioration chain on which this actual process is dependent. It doesn't address those things which we need to build. If we want to use this over a whole network and over a whole bridge stock, the prioritizing will come only when we truly implement a full bridge management system, which is yet to be done, sir. This is the point I think Sinha Sahab was making.
Point.
Yeah, very good, very good. Thank you very much. So, and this prioritization will come. That is a part of the situation. Otherwise, you can't, repair all the bridges at one time. That is bound to come.
Okay. One of the participant, engineer Aditya N. Pandey, yes, sir, truly agree. We should be vigilant and volunteer to inspect. Oh, some of them, they are responding. The defects in bridges, okay.
My point is that any voluntary inspection is not required.
No.
There has to be some training. They will only inspect.
Yeah.
But before training, if they inspect, I told you that I go and see, oh, this is very serious. And somebody else goes and says, oh, it's very usual thing.
Subjective.
There are two different views seeing the same crack. So, this can be. So if I say, if I go on be vigilant, that does not
No.
give you the correct answer. You must train yourself, which is, and if I say it is serious, then second person who goes there, he will also, it is serious.
Yeah.
That should be the, that is
That
the
kind
idea
of
of the match. Otherwise, if I am not trained, or the other person is not trained, then they will not match. The ideas will not match.
Yeah.
The result will not match, rather.
Yeah. Okay, sir. I think we are now going to thank you, sir, for keeping ourselves active, and with
Thank
your
you.
60 plus years of experience, that keeping you also active and energetic for long way that we have to go together. And Dr. Subbarao sir, please, we'll be very happy to take those, integrate those things into this inspection process, so that finally also we bring some kind of inspection and training also into that, where NIDM also will be there, CIDC will be there, your organization also will be there, and we'll bring it together.
I think for the benefit of our friends who are basically wanting to understand the gist of it in Hindi, let me just explain. What has been discussed is, ये बात क्या हुई है कि हमारे पास में जब कोई काम करना हमको होता है, सबसे पहले तो हम ये तय करते हैं कि इसकी ज़रूरत क्या है। तो सबसे पहली ज़रूरत ये है कि जो स्ट्रक्चर हमने बनाए हैं, ये स्वस्थ रहें, ये अच्छा काम करते रहें। और जैसा कि पहले मैंने बताया था कि कुछ बच्चे पैदा होने के समय कमज़ोर होते हैं और कुछ बाद में कमज़ोर हो जाते हैं। तो क्या कमज़ोरियाँ आती हैं, वो सारी कुछ बताई गई। और साथ में हम फिर ये अंदाज लगाते हैं कि कितने लोगों का इलाज करना जरूरी है। ये स्टॉक लेना भी बहुत जरूरी है। ये स्टॉक लिया गया और इसका स्टॉक का कुछ नंबर आप लोगों को बताया गया कि आज की तारीख में इतने किलोमीटर लंबी सड़कें देश में हैं और साथ में इतने स्ट्रक्चर हैं और ये स्ट्रक्चर बनते ही जा रहे हैं, ये कम नहीं हो रहे हैं, बन रहे हैं और हम इनकी देखरेख के ऊपर में ध्यान नहीं दे रहे हैं। तो वो ध्यान देने के लिए ये आवश्यक है कि हमारे पास में ऐसे लोग हों, ऐसी संस्थाएं हों जो कि इस काम को सुचारू रूप से कर सकें, समझ करके कर सकें और अच्छे ढंग से कर सकें। कुछ प्रयत्न किए गए पीछे मिनिस्ट्री में, सिन्हा साहब जैसा बता रहे थे, लेकिन उन प्रयत्नों को शुरुआत करके उसके बाद में फिर आगे बहुत बढ़ाया नहीं गया। तो अब जो बताया जा रहा है वो ये कि ये काम इतना ज्यादा बढ़ता जा रहा है कि शायद लाखों लोगों की आवश्यकता पड़ेगी जो इस समस्या का निराकरण कर सकेंगे और जो स्ट्रक्चर हमारे बने हैं उनको सुरक्षित रख सकेंगे। देखिए, एक बात समझिए, जो भी स्ट्रक्चर हम बनाते हैं उसमें देश का पैसा लगता है और हम चाहते हैं कि वो लंबे से लंबे समय तक स्ट्रक्चर बना रहे, जाए नहीं और अपनी यूटिलिटी देता रहे। तो ये तभी होगा जबकि स्ट्रक्चर स्वस्थ रहेगा और स्वस्थ रखने के लिए इन्वेस्टिगेशन करना जरूरी है बहुत ज्यादा। और मैं बार बार तुलना देता हूं आदमियों की स्ट्रक्चर के साथ। जैसा आपका इंस्पेक्शन होना जरूरी है, डॉक्टर लोग आपको चेक करते हैं, उसी तरीके से इनका इंस्पेक्शन भी जरूरी है। लेकिन उसके साथ ज्यादा जरूरी बात यह है जो सिन्हा साहब ने बताई कि जब तक कि आप जानकार नहीं होंगे इन चीजों के बारे में कि क्या चेक करना है, कैसे चेक करना है और कौन से विधाओं का प्रयोग करना है, तब तक आप इस काम में नहीं लग पाएंगे। तो सीखना आपके लिए बहुत जरूरी है और हमारे वो सभी साथी जो कि अपना कैरियर बनाने जा रहे हैं, उनके लिए ये एक बहुत अच्छी दिशा है जिसमें कि वो जा सकते हैं। तो दिस इज द समरी एंड आई थैंक यू डॉक्टर सुब्बाराव। द इशू दैट यू हैव रेज्ड इज एक्सीलेंट। द only thing that I have on my plate is that it is almost like starting from scratch. There has just not been much which has been done. There had been number of discussions, deliberations, seminars, conferences, but you know CIDC and the activities of CIDC, and we are the ones who put our money where our mouth is. तो अगर हम बोलते हैं कि हम ये करेंगे and if we want to do this, then it is certain that we are going to be doing this. So One example that I would like to give you is basically the national flagship program of skilling the workmen in the construction industry. The credit entirely goes to CIDC, guided by stalwarts like uh, one of the major stalwarts and motivator in this particular area happened to be your father. I'll always keep on remembering the grand old man. So, but then he told me something. He said, look here, my boy, you have to make sure that if you embark on this, you are not going to leave it midway. And it is almost like 20 years. That's a homage that goes to the old man, that this program is not only strong, but also a national flagship program. So what we hope that, as suggested by Mr. Sinha, we would be in a position to do few things. And I have many young colleagues who were born not were born the year Mr. Sinha graduated in Dr. Chandan Ghosh, who is going to be helping us out with an IDM, and we will have the DG of DG Roads joining us, and of course all of you are there. So it's a very powerful and strong family, and we'll take it up further. So Dr. Ghosh, I think we can invite Professor Parmeshwaran now, and although we are slightly off the time, but I think we are going to be listening to that. अच्छा, जो लोग हिंदी में समझना चाहते हैं उनको मैं एक बात अभी बता देता हूँ कि आप लोग तसल्ली से सुनिए और उसके बाद में मैं इसका अनुवाद जो है वो करूंगा आपके लिए, क्योंकि डॉक्टर परमेश्वरन जो हैं वो शायद उतनी अच्छी हिंदी में आपको न समझा पाए, तो वो अंग्रेजी में बोलेंगी, मैं उसका अनुवाद करूंगा उसके बाद. तो लेट अस हैव डॉक्टर परमेश्वरन नाउ, प्लीज.
Thank you, Dr. Sarup and Sinha Saab, and also Dr. Subbarao, mentioning about his father. Oh, yeah. So let us work together. And now the last presentation of today is on road bridges structural health checking system by Dr. Lakshmi Parameswaran from Central Road Research Institute. She is a chief scientist there with 34 years of research and development R&D experience, and she has guided their number of MTech and PhD students also. She is a civil engineering PhD from IIT Roorkee and also founding chairperson of academics and was coordinating the MTech and PhD program offered at CSIR EXA. She has authored more than 120 technical papers in journal and conferences, 150 technical reports, and then on various codes and practices related to bridges and structure. She works in bridge aerodynamics, structural health monitoring of highways and railway bridges, bridge management, wind tunnel testing. She has significantly contributed to the development of bridge management system, which we are just talking before, bridge management system and mobile bridge inspection unit at CRI. She is member of many bridge committees, including Indian Road Congress, and she is a recipient of Boy Scout Fellowship from the Department of Science and Technology, Government of India, and she is also a visiting scholar at Johns Hopkins University, USA, the famous university who are maintaining COVID data, and many other organizations. Okay, welcome. Let us welcome Dr. Lakshmi Parameswaran. Is she here?
Yeah, I'm here, sir. Good afternoon, Dr. Swaroop, Professor Ghosh, and my colleague Dr. Harshvardhan Subbarao, and Mr. Sinha, and all other participants. I am grateful to Professor Swaroop and Professor Ghosh for allowing me to participate in this conference. And also I am grateful to Prabir, who has been roping me into this event. And I will just share my screen.
Lakshmi, allow sharing.
Allowed, sir, already given.
Okay.
I am not able to see my this thing. Let me see.
Ma'am, downward there is a share.
Yeah. Is it visible now?
You are coming in.
Yes, ma'am.
Yeah. I hope you are able to see it.
Yeah, it is there. It is there.
Okay. So good evening. So my presentation is on road, bridges, structural health checking system. And we have been listening to Mr. Vinay Gupta and also Mr. Sinha, and who gave like why we have to go for this structural health checks, just like human beings, bridges are also having various components. And nowadays we are designing the bridges for 100 years. So probably the longevity of a human being and bridges are also somewhat similar. And we have also different organs like that. Bridges have different components to transfer the load from superstructure to the founding soil. So I will just give a brief outline of my presentation. Why the structural health assessment of bridges is difficult. I will give a basis for that with the introduction of road bridge types and the type of distresses that are likely to happen. Like Dr. Swaroop said that some of the bridges are constructed with some deficiencies. Okay, then over the year they deteriorate, and then sometimes like they are damaged because of some external action. So I will be talking about the defects, I will be talking about the damages and the deterioration. Then what are the methods available for structural health assessment? Then like the non-destructive techniques, that is the structural health monitoring and non-destructive evaluation. And what is the future technology? Because we have large number of bridge stocks. So how we can do a quick survey of that? So the non-contact technologies are coming in a big way. The non-contact technologies, I would say that there are some non-contact sensors as well as some non-contact systems. So all these things are coming. So that will be the future. And you have to understand that it is not only the civil engineers who will be involved in this, but also the other branches of engineering, like electronics engineer, mechanical engineer, then the computer engineer, communication engineer, all these people will also be involved. So probably you can train more people for this work. Coming to the type of bridges what we construct, you will see that in the last 56 years, Mr. Sinha Saab will agree with me that there is a change in the way we are constructing the bridges. Earlier, the bridges used to be like simply supported, and very few like balanced cantilever bridges were there when it was like over a river. Like nowadays we have moved from the simply supported to the continuous structures. So continuous bridges like 3-span, 4-span, like that they are being built. And earlier most of the road bridges, they were of reinforced cement concrete, and subsequently we moved to the prestressed concrete bridges. But now last 2 decades, if you see that there are more number of segmental construction, pre-car segmental construction bridges, they are being built. And also like we have gone into like steel concrete composite construction, where we have the steel girders with a concrete deck over it. And we still have very old masonry bridges, and they are something like 100-year old. And recently we visited one bridge. My colleagues visited a bridge. Actually, it is a 2-level bridge and 145-year-old bridge in Unnao. Actually, the bottom lane is used for pedestrian and top lane is used for the vehicles. And it has a 22-meter tall pier, which is made of bricks. So the way in which we construct the bridges and the hello, Pura. Okay. So the way in which we construct the bridges, that has changed like a lot. And you would see that we have some steel alone bridges like the Howrah Bridge. And here you have to understand that this bridge was constructed in 1940s and still under good construction, good condition. And you have to understand that why it is happening. After the construction, they are following a particular SOP to maintain this particular bridge that was given by the designers. Okay, so that means the periodic maintenance of the structure, you can elongate the life of the structure. Then I think this is the arch bridge, which you have seen. This is the pedestrian bridge, which Mr. Vinay Gupta also explained. But we have now large number of arch bridges being constructed in the roads also. Actually, what we have to understand is that the structural behavior of each of the bridges, they are different. Okay, so how they behave under the load, that is one important aspect which one has to understand. So because of the behavior, where the problems are likely to happen, that is one important starting point for anybody going for the bridge inspection. And what is now happening is there are number of like extradose bridges coming, cable stayed bridges are being built, suspension bridges are also being built, especially in the hilly regions. So there, apart from the deck and the pier, like there are like cable elements which are also coming. That means more number of elements are also coming. And also as the span of the bridges are increasing, the type of the bearings, what is being used, type of the expansion joints which is being used, they are also different. So altogether, like there is a improvement in the material which are being used for the construction, the structural arrangement is also changing, and how we are constructing the bridge, that is also changing. So there are a lot of advancements in the construction of bridges. So that is why the structural health assessment is also quite complex. Now coming to the defect part of it, that is the distress part of it. This was a almost newly constructed like bridge. It was having pre-tension girders, and over which there was a cast in situ deck slab. And you can see the deck slab concrete was not that good. That's why like it has some sort of a honeycombing, and even you can put your hand. This is beneath the, you can say the bottom of the slab. So this sort of construction, definitely this will lead to the problem over the period of time. And also even when the vehicles were passing, some of these concrete was falling down. And Dr. Swarup talked about the construction deficiencies, that is the bridges which are born with some problems. The first top figure, I think I will try whether I can pointer. Yeah, highlighter. Yeah, this one, actually this is a multi-span simply supported bridge. But actually here there was a deficiency in the detailing of the reinforcement. And because of which after 20-30 years, like all the pier caps, they developed the vertical crack. And the crack was quite visible from far away. Then they said that, okay, this has to be investigated. So this was due to the improper detailing. And you can see that most of the piers, what we have inspected, they have less cover. Actually, though we say that because of the durability consideration, you have to provide 40 mm cover or 50 mm cover, but the cover block size is not fixed, or they are not properly fitted, and you get very less cover. And if there is less cover, the reinforcement is exposed, and that itself becomes a point through which like the corrosion can get initiated quite quickly. And another type of distress is the damage. Actually, there are two types of damage which happens because of the vehicular movement. One is because of the over height vehicles. The bottom figure shows that actually this is a bridge which we inspected, which was quite close to the Tata Steel in Jamshedpur. Actually, like a lot of like trucks carrying the steel material from the steel factory that goes, and that hit the, you can say, the bottom girder, and then you can see the damage which has happened. So something hitting that causes some sort of a damage. Okay, and this one you can see that the Howrah Bridge, again some barge hit this one, and there was some problem to that particular bridge. So either by hitting like this sort of damage can happen. And another is about the hydraulic trailers. Actually, along with the development of the road network, like the other structures like thermal power plants and other things are also coming up in big way. And you will see that these hydraulic trailers, they have large number of wheels provided, and they carry undivided goods from one place to another, like the thermal power plant equipments, etc. And because of which, like one bridge in Gujarat, this collapsed, one span of it collapsed, and this happened in 2009. And another balance cantilever bridge in Madhya Pradesh that collapsed in 2011 because of the passage of the truck carrying heavy turbine. And this led to us to study why this happened. And then like a committee was formed, and they did a lot of studies. And then they found that there are some 30 different type of vehicles pass over the bridge of this type, that hydraulic trailer type. And because the road bridges, they are generally designed for the 70R loading, that is 100 ton with the impact factor, etc. It may come to be say 150 ton, but these things carry something like 300, 400 ton. So whether it will be safe, that is the question. So that is the reason why like this special vehicle which Mr. Vinay Gupta was showing you, that was introduced into IRC6, so that at least the bridges which are being built after that, they don't collapse like this. Okay, so that is the reason why we introduced this. But still, like there are certain requirements for this vehicle to ply. That is, it has to go through the center, and there should be no other vehicle when this type of vehicle passes over the bridge. And also there should be some, if some heavy high wind or something is there, then you should stop it. So many things are there, and before you allow such vehicle to pass over, you have to do a condition survey and see that the bridge is in good condition, then only you can allow that. So there are a lot of requirements before you allow such vehicle to pass over the bridge. And another thing is the damage which caused because of the natural calamities like earthquake. Like the earthquake can cause because it's a transverse movement of the deck, it can cause some longitudinal movement, or like it can cause some vertical movement of the deck. And if such thing happens, then you are not able to drive a vehicle over that particular deck. So these things can cause some sort of a damage. Another is something like a ponding of the structure, or there can be some shear failure, or again because of the improper confinement there can be some crushing of the concrete and the vertical longitudinal bars what you provide in the column that may get buckled. So all sort of things happen. So that's why this IRC SP 114, the guideline for seismic design of bridges that was published, how to do the design of these bridges so that such failures don't happen. Now, as I told you, the distresses we see in various components. So even the wearing coat of the bridge, either it can be a bituminous wearing course or it can be a cement concrete wearing course. And you will see here that like what is the condition. And this is a major bridge what we inspected. And you can see that we provide the expansion joint to take care of the expansion and contraction of the bridge decks. But you can see that in most of the cases after the construction of the bridges, nobody maintains the expansion joint and they are in a jammed condition or they are with some broken members because nobody take care of it. So the question asked, why like they are not being maintained, why they are not being inspected, even they are not doing the cleaning. Actually, we have to understand that ours is a developing country and we are putting all our efforts to like create a road network or develop a road network. And what we have the money for the inspection and maintenance, the maintenance of the bridge is quite low compared to the number of structures what we have. And what is being happening is there is no systematic inspection and scientific way of approaching the problem, prioritizing the bridge for the repair or rehabilitation. But in most of the times it is like if it is an emergency situation or if some elections are coming, then that becomes a time when people think about this bridge and they will say that, okay, you inspect the bridge, you give the rehabilitation plan or repair measures, but they may not do it. And that also happens, it may happen after 2 or 3 years. So probably the condition would have deteriorated if timely intervention is not done. Then the deterioration can be due to the mechanical action on different type, and there can be cracking due to the repeated traffic. And another major problem is India has a vast coastal line, and we have a number of bridges there, and also we are going to have the Sagar Mala project, etc. So maybe large number of bridges will be built also. But corrosion of the steel, which is embedded in concrete, that is just like a cancer problem. Actually, when we go for inspection, we will be able to see a brown discolorization on the surface that will indicate that there is a rusting of the steel that has happened. Then what happened is that when the rust forms, like it expands and it will impart pressure on the concrete, and the concrete which is weak in tension, that will crack, and you will see that first one crack is formulated, then like there are multiple cracks happens, and this particular portion becomes separated from the original structure, and we say that it is the delamination. After delamination, this portion just falls out and then it becomes exposure of steel. And we generally say that if you see that what is the remaining life of the structure, that it takes into account what is the time required for initiation of corrosion, what is the time required for propagation of corrosion. The initiation of corrosion will depend on whether the corrosion is due to either carbonation or it is due to chloride attack, and what is the cover what you have provided. So the cover what we provide, the quality of the cover, they are very, very important. Okay, if you have a very good dense cover, then probably the deleterious agents, they may not be able to get into the system, and the corrosion may get delayed. And the IRC6, they have specified some additional measures also, like how you can minimize the corrosion or delay the onset of the corrosion. And I think Mr. Sinha ji has told all about the different type of inspection, what is to be done, like routine inspection, detail inspection, special inspection, and I will add here underwater inspection also, because when we are not inspecting even the structures which are over the ground level, what to talk about what is there beneath the water. So why we do the routine inspection is to identify the factors which affect the bridge appearance and geometry. So if you go and see when a person goes or walks over a bridge, he can see some cracks or say spalling or exposed reinforcement, or you can see here that sometimes the expansion gaps are unequal, and even sometimes that becomes too big that even a wheel of the motorcycle that will get entangled, and people may get injured, or even some people they have died because of this. So that can lead to accidents. So it will affect the safety of the people. So this is one why we do the routine inspection. And in the case of steel bridges, what we see is the painting or protective coating, how it is, or whether there is a generally before if the span of the bridge is more than 35 meters, then provide a camber. So whether there is a loss of camber or corrosion or some bolts have been missed, all these things you can see if you do a routine inspection. And in the case of detailed inspection, actually it is a quite elaborate one. So there, like, you have to identify, like for various elements, there are checklists given. So you have to inspect them in detail. That is very much required, which is quite time consuming also. And there are certain special inspection which is to be done after like natural calamities like earthquake, flood, or cyclone, or sometimes the vehicle which is passing over the bridge, or like one goes beneath the bridge, that may catch fire. So the bridge may get damaged due to fire. So basically the special inspections that is done, whether the bridge can be open to traffic after these special events, or sometimes, as I showed you earlier, that impact damage of pier or girder, or post local failure. So this needs some special inspection. Now coming to the underwater inspection, actually, like I think during the 12-5-year plan, I was working for some time, like whether just like the mobile bridge inspection unit, we can also develop something for the inspection of the bridges, the bridge components which are beneath the water level. Actually, like in the case of superstructure elements, like you do a visual inspection, but in the case of underwater, like you, the general method is like you employ some divers who can do some sort of a tactile, that is by touching they can see whether the bridge surface, the component of the surface is in good condition or not. And then there are some detailed inspection they do after doing some sort of a partial cleaning. Why the cleaning is required? Because the bridge component which is in the water, that will have some fungi growth and other thing. Then highly detailed inspection with some non-destructive testing. So these are some of the 3 types, but I think there are certain remotely operative vehicles which are also being used for this type of inspection. And though I tried something which was at the laboratory level, but I found that like it requires some mechanical engineers skills, and then like the communication engineer skills to put the various sensors into it and all. So some sort of a laboratory scale thing only I could do it. But I found that some young engineers in Chennai, they have developed some sort of a remotely operated vehicle, IROV, and they have a cloud-based image processing tool called EVAP. And if you want, you can see this irov.com for more details. And they came to, they made a presentation to us. Actually, they have used this particular ROV for inspection of many of the railway bridge foundation. In fact, the idea for the underwater inspection also came into our mind when Northern Railway approached us whether we can do the inspection of the bridge piers. But what we found that the water in Yamuna, that is all brackish and no diver is willing to go there to do the inspection. So that is why we need some sort of a system where there is no manual intervention is there, like at least they don't have to go into that dirty water, because even the brackish water, the visibility is very poor. So that's why like this ROV system will have a camera and a lighting source so that if you go close to it, then you are able to see. But there are some challenges in employing them also. And even they can be used for the inspection of the culverts. Mr. Sinha was telling that there are something like 134 culverts in NH alone. Okay, so if you take the total number of culverts in our entire road network, it will be much more. But I think regarding the culvert, I think probably after the construction, nobody goes close to it. So they may not be even seeing what is there inside. So because the diameter of the pipe, what we use is like maximum 1 or 1.2 meter, and people cannot, box culverts are there, but again, the water will be very dirty and a lot of vegetation growth around the culverts. So people don't want to go there and see it. So in such cases, like we may have to do some sort of a automation for the bridge inspection. Now coming to the equipments required, we need access equipment, we need measuring equipment, we need recording equipment and safety equipment. And this is the mobile bridge inspection unit, which was developed by CRRI and CMERI. And why we went for this inspection unit is, in fact, one of our colleague, he himself fell down while we were doing the inspection. When it came to our mind that, okay, safety of the person who is doing the inspection is also very important. And you can see that it provides a platform beneath the bridge, and by standing here, somebody can look close to the underneath of the bridge, and they can do some sort of a non-destructive testing, or they can do the repairing, etc. So that is the advantage of this particular system. And in fact, this sort of this MBIU was used in the IBMS data collection by Ministry of Road Transport and Highways. So I think now most of the states they have, or many of the consultants, they purchased it, because that has become a mandatory that these mobile inspection units are to be used for the inspection of the bridge. Now coming back, what we see when we do the inspection, actually it is not that simple. That actually there is a lot of training required for the people who are going to do the inspection. Why? Because actually the distresses what we see, they develop because of various processes like chemical process, physical process, or mechanical action, or electrochemical process. So what a person see, maybe some sort of a efflorescence, maybe some white color on the concrete surface, that may be because of the leaching, or there may be like some cracks and gradual disintegration of concrete, maybe because of the sulfite attack, or there may be like not properly, you can say compacted concrete was there, especially like you can see that in the pre-stressed concrete bridges, very close to the anchor zones or the anchor zones, like you will see that in many cases, unsound concrete is there. Then that it may be due to alkali silica reaction. I think Mr. Sinha was explaining. But all these things, one has to understand that whatever you see on the surface, why it is happening, and whether it is a chemical process, physical process, or mechanical or electrochemical process. Because it is just like when you go to a doctor do a checkup of you, and maybe you have a fever, but he has to understand why the fever has come, whether it is because of a throat infection or some stomach problem or some other problem. Okay, like that also, the cracks may be due to various reasons, but we have to understand what is the cause of this crack, why it has happened, because the remedy or the repair or intervention will depend on the cause of the treatment will depend on cause of why it has happened. Even like the doctor will give different antibiotic if you have different problem. So similarly, here also there is a requirement to understand, especially the specialists who are leading the inspection team. They should know like all such things. Okay, for example, it is not only like you see where the crack has happened, the direction of the crack, the orientation of the crack, the width of the crack, all these things are important, and you have to link them with the possible cause. So that is very, very essential. As I told you, like earlier, maybe in 50s and 60s, we were having more number of only reinforced concrete bridges, but we have now the pre-stressed concrete bridges also. So the pre-stressed concrete bridges, how the load transfer is happening, depending upon the type of construction, what they adopt, that also one has to understand. So depending on the direction of the crack, like you may have to understand the cause by which it has happened. Now, what the IRC codes do, basically, they say that what are the things to be inspected, okay? And after you get it, they only qualitatively state whether the bridge is in the bridge component is in excellent condition, good condition, fair or poor, or it is in critical condition. The bridge is in a critical condition. That is, the inspection data only give you a qualitative judgment for the condition statement. But whether for doing the prioritization, this will not help. You have to do some sort of a quantitative assessment. Then only you will be able to rate the bridges. So that is the purpose of doing the inspection. I would explain for the people who are there to make them more understand, like it is just like you have 60 people in a students in a class, okay, and the teacher rates the student depending on how much marks they get, so that the people who are not performing well, the teacher can work more on them, or the student can put more effort so that he can come to a better level. Here also, like we have to maintain the structure at a particular level of service, okay? It will be very good if you keep the bridges in an excellent condition, okay? But to keep them all in excellent condition, you need a lot of money. But ours is a developing country and we have limited resources available. So we may have to take a decision, okay, that what level I should maintain the bridge, so that the budget what I required will depend on like the level in which I want to maintain my bridge. So that particular decision has to be taken. And also we have to take a decision like which bridge I have to attend first. Okay, because I have say 1,000 bridges in my road network. Okay, so which one I should first do the repair, so that the road network is available to the user. Ultimately, the users should not be affected. That is the aim, because their safety and also the time, that is also quite important. And also I have to do all those things in the limited budget. So there is a lot of challenge for the engineers who are maintaining the bridge. Now coming to the structural health monitoring. Basically, if you say what is structural health monitoring, it is a non-destructive in situ structural sensing and evaluation method which uses various sensors which are attached to it or embedded. I think most of you, like you must have done some sort of an ECG either for you or your family members. So they put some sort of sensors, and then they see how you get some sort of a, you can say, a signature, how your heart is working. Okay, like that, like you have certain sensors available, but you have to understand that none of the sensors are going to tell that, okay, this is this sort of damage is there. That information it is not going to give directly. But what it says is that it will give some sort of a indication of the performance. So that what I want to say is that what we are going to do by the structural health monitoring is we are going to monitor the performance of the structure. How do you measure the performance of the structure? That is, when you do the design, you say that, okay, there are certain serviceability conditions, that the crack width should be limited, the stress at the serviceability condition should be less than this particular value, or the deflection limit, it has to be less than this value. All such things are there. So here also, like it involves a lot of sensors, like you can measure the strain, you can measure the displacement of the structure, you can measure the acceleration of the structure. So, and these things will help you to estimate the severity of damage or deterioration. Okay, even there are certain sensors which can see the rate of the corrosion. You can measure the temperature, and the sensors are of different type. And most of the time, the sensors are to be fixed on the surface, or sometimes while construction, you have to embed them on the steel of the steel which is there inside the concrete. Okay, so why we have to adopt this? Because this is an experimental verification of the design procedure. Because I talked about that there are different boundary conditions for the bridges, like it may be either simply supported, or it may be cantilever, or it may be continuous bridge. So whether it is behaving the way in which you have designed, or like over the period of time, because we have only 100 years design life, and what the traffic we see now, that may not be there in the future. It will be quite high, because I will say that maybe in 1960s and all, there were more number of 2-axle trucks which were plying. But if you see now, many states, they don't have 2-axle trucks. It is all 3-axle trucks, 4-axle, 5-axle. That means multi-axle trucks are there. And also, if you see that there is lot of overloading there, and in addition to that, we see that some sort of a special vehicle like hydraulic trailers, they are also going over these road bridges. Okay, so the health assessment for increased service life. I think the same thing happened with the railway also. I think the railway also increased the load carrying capacity in their wagons. So because of that, they checked, okay, whether the bridges are safe, because the bridges are, most of them are 100-year-old bridges. Only thing in railway, it is a controlled traffic, okay, and they have a data of how much vehicles are plying and what is the load they are carrying, all such details they have there. But in the case of road bridges, like you don't have any details of what type of vehicle is plying, except I think probably the special vehicles. The condition assessment of age structures, again, like I think what Mr. Sinha was telling, we have large number of bridges for which we don't have any drawings. So without the drawings, like to understand the bridge, or what type of reinforcement is provided, or what is the pleistocene provided, it's all very difficult. And we don't have any details of what type of foundation is there for such bridges, or how deep it is going. We don't have any soil report. We don't have any data related to the bridge. So how do you do it? Then life extension beyond design life. Or maybe you can say that you are doing some intervention on the bridge, some rehabilitation, and after that, the efficacy of the strengthening measure, you can check it if you do a structural health monitoring. But everything comes with some you can say some cost to it. So there are different, you can say, classification. First is that there is a damage there or not. Okay, then where the damage is there. Okay, then you classify about the type of the damage, and then you have to understand to what extent the damage has happened. That is, what is the severity of damage. Okay, then the fifth one is, if you have a problem in a bridge, but you don't have money to do that, what will happen? Okay, so whether the safety of the bridge you have to ascertain. Okay, and also you have to see that, okay, I'm not going to get money for repair for next year and for 2 years, then what will happen? So some sort of a residual life you will have to work out. So all these things will be possible if you do a structural health monitoring. But as I said, it is not only civil engineers are required. Probably their role will be to plan the scheme and also like to interpret the data. Okay, because you have different type of sensors. So first question will be, what type of sensor I have to select, where I have to put the sensors, install the sensors, what type of data acquisition system I should have, and at what time interval I have to do, whether it should be a periodic monitoring or it should be a continuous monitoring, because everything is associated with cost to it. You have to maintain the sensors, you have to do some calibration of the sensors. So all these things are important, that how to transfer the data. And if you do a structural monitoring, you get a lot of data, but ultimately you have to interpret what it says about it. So there needs some computer engineers, some networking engineers, and then somebody to take what is useful from the data. So whole sort of things are involved. So the contact sensor system, actually, when we started the structural health monitoring in 90s, we have done for some 6 or 7 bridges at that time, but it was all the wiring system. That is, all the sensors were with the wires. And what happened was that some people, because our bridges, unlike the railway bridges where some security is there or somebody is there to see that nobody is coming close to the bridge, here nobody is there. So some people, they have cut that particular wire. So then we are not able to do or retrieve the information from that particular sensor. So the deployment and operational cost associated with the installation of sensors and communication system. And then maybe if you are constructing and the initial few years, okay, the requirement may not be that much, but the later part, like for the maintenance part, like this system should be there. So how long this SHM has to be there? Because we see that in many of the tenders of the bridges, it is there for 5 years. But whether 5 years is only required or you need something more, but whether such a system or data acquisition system, they will work for 5 years, or whether you are going to get data from all of them, or some of the sensors may go bad in the a longer period. So there are so many issues associated with these sensors, data acquisition system, communication system, storage, retrieval, etc. So that's why I said that it requires not only civil engineers, but also from other branch engineers. Then another question comes, like we said that because both this SHM and the non-destructive evaluation, both are basically non-destructive work only. But actually the NDT, what we see, that is actually some sort of a one-time assessment of condition of material at a single point and the effect or extent of deterioration in the structure using some external equipment. Okay, that is for some localized damage, like we will be able to use this NDT. But actually the SHM, basically it gives the response of the structure under various type of load. And it may be like, for example, we were doing the monitoring of the bridges during summer and winter. Why? Because the thermal effects on bridges, that is also quite vital. So we were doing that sort of monitoring during summer, during winter. And even for the railway bridges, we were doing like number of times in a year like that. Now the question is, like at present, like we do have some standards, some guidelines for the non-destructive tests, but we don't have any standards available in India for structural health monitoring. So that means I think in 90s when we started the structural health monitoring, people were not able to even accept it. But probably now the mindset has changed and people are ready to accept the structural health monitoring. So if you see the standards which are available, if you see the other countries like Canada, they had the guideline for structural health monitoring in 2001. And in European framework, they have it in 2006. And there are certain ISO standards that is available for the evaluation and measurement of result by the dynamic test or investigation of bridges. That is like the dynamic response you see, and from that you do the damage detection. So for that, they have the standards available for that. And these are like the test methods, what is prescribed in IRC SP 35. And you will see that they all have some reference, which is other than some of the foreign standards also. Because in many a times you will have doubt about the quality of the concrete, or so that is why like you have either the pull-out test or the Windsor probe test or rebound hammer test, or then you do a core test to verify, okay, what is the compressive strength. But you cannot take so many cores from a bridge because you should not damage a bridge by taking so many cores. So that's why you may have to go for the non-destructive test. Then, as I told you, many a times you don't provide a proper cover. So the cover also has to be checked. Or when you have to take a core from the bridge, you have to identify at what location you have the reinforcement. Okay, so to check the cover of the reinforcement, so by which you will identify the location of the reinforcement also. So that means what I want to say is that the different type of equipments are being used. They may be mechanical, electromagnetic, or hydromechanical. Then there are series of tests which can be done, like to identify the corrosion sensitivity. Okay, that may be either like you have to see whether there is a probability or risk of corrosion or rate of corrosion, like you have different methods. Then you have to identify whether the corrosion which has happened, it is because of carbonation or because of the chloride attack. So the depth of carbonation, you can do it with the carbonation test. Then there is another method that you can just take a sample of the concrete and do concrete powder at different depth of the cover, and then you do a titration and then see, okay, at till what level like this carbonation has reached, or whether there is a chloride is there. What is the limit value of the chloride in the concrete, so that you can see what is the likelihood of the corrosion happening. Then this petrography, that is for the alkali silica reaction. Then you can do some chemical analysis, actually like the water which is flowing through the culvert or the soil in which you have founded the bridge, that may contain sulfate. So the foundation is prone to the sulfate attack, like your pile, they may get affected, or even the open foundation or the culverts, they may get affected by the sulfate attack rather than the superstructure. Then there could be permeability, because you have not done a proper compaction, and most of the times the presence of water is required even for the corrosion to happen. So again, there are series of tests which have been specified. Then the homogeneity and quality of the concrete, this ultrasonic pulse velocity test, then acoustic emission that can be used for the internal cracks, then the dynamic response technique for the pile integrity, and the voids, then the ground penetrating radar, endoscopic tests, thermographies, like that. A series of tests can be done to identify the cause of basically to severity of damage and to understand the cause of the distress, like all these things can be done. Okay, so this has, I think, to some extent explained in IRCSP 35 and also various other standards, how to do it. All such things are quite clear, okay? But you require a lot of sophisticated equipments, which are quite expensive. Such requirement is also there if you want to really maintain a particular, maintain large number of bridges. Now, the methods of health assessment of bridges. So I would say that there are 3 types of possible inspection method. First is the in-person inspection, like visual inspection. We don't realize the importance of our eyes, okay? Because if you see the cost of the camera and their ability, what they will be able to do, then we should thank God for giving us our eyes. So the labor intensive and the visual inspection may be by walk or by binoculars, and sometimes like you may have to use it from some boat. And as Mr. Sinha was telling, it is quite subjective. Unless the person is properly trained, then what 2 persons see and judge, they may not be the same. And it does not provide quantitative information. As I have shown you earlier, it only gives a qualitative judgment. And many a times it requires some sort of an inspection unit, like mobile inspection unit. And these inspection units are quite expensive, either to buy or to rent. Even if you own one, many a times we see that they are not in good condition because the maintenance charges are also quite high. And MBAUs but provide inspectors with a close and hands-on view on the structure, which I showed you with some photographs. Then, but for doing that, you may have to disrupt the traffic lane closure. Traffic, that is, the lane closure may have to be taken, or some traffic diversion will have to be planned. And damage inspection may not be possible with MBAU. Damage inspection means you understand that, like, suppose like the bridge is affected by earthquake, or like there is some fire damage. Such cases you may not be able to use the MBAU, because the MBAU will have to be moved over the bridge. Only the arm comes beneath the bridge, so it may not be possible. So what is the other method available? That is a robotic inspection. So there are certain robots. One, I told you that there is a remotely operated vehicle which has been developed in our country for underwater inspection. But there are some robots available, not in our country, but I think in US and other countries. They provide comprehensive condition assessment of concrete bridge deck. They are faster than manual NDE without compromising the data integrity or resolution, and it improves the speed of data collection and analysis. Actually, what we get from visual inspection, like you have to then build a database, but here the data comes automatically. So there is no manual intervention or manipulation of the data. Then less technicians are required, less traffic disruption, and saves time and money. Of course, they are quite expensive. That is, initial amount required is quite high, but they run on battery, so minimized environmental impact and improve safety for inspectors and drivers. And the third category, which is coming up, is the unmanned aerial vehicle or unmanned aircraft system. Some people call it like that, or some people say it is a drone. There is less manpower requirement. It is faster, safer, reduced inspection costs because drones of different types are available, disruption of traffic for less time. But there are certain difficulties or challenges, that is to stable the unmanned vehicle for capturing the photo if there is a wind or turbulent condition, how to control it. So there are certain challenges for each type of these things. So you can see that the robotic platform, like there may be ground-based, like as you can see that it is over a surface, or it may be something which is crawling, or it may be climbing, or it may be aerial or marine propulsion, and it will have some capability for navigation, localization, map building, inspection management framework. Then there are inspection technology, that is imaging technology, and certain non-destructive evaluation. So you can see here that this is the one which is used in US by Federal Highway Agency, and many of the states they are adopting. It is called Rabbit, and it has, you can see, there is a GPS system for getting the coordinates. There is a ground penetrating radar, high definition imaging system. Then it has ultrasonic surface waves to assess the quality and modulus of elasticity, because that will indicate what is the strength of the concrete deck. Then impact echo to detect the delamination, because otherwise for delamination, the easiest thing, that is to tap the surface with a hammer, or like to drag a chain to, and there will be a difference in sound. So that will indicate that there is a delamination. Probably some people say that that was the first step to use some small equipment for the health assessment. Then electrical resistivity to diagnose the severity of corrosive environment. In fact, for road survey, CRRI has a network survey vehicle, and it has been fitted with various cameras and laser sensor, etc. So that goes over the road, and because the road, the length is too much, so it goes at say 30-40 km per hour, and it collects the data, and then they do the processing of the images, and then they find out what is the distress over the road surface. And we have a ground penetrating radar recently we procured in our institute, but we don't have a complete robot like this. And another important aspect is the robot for the stake cable inspection, because now we are having the extradose bridge and cable stayed bridge also being built. And some of the cables, they are 100 to 300 meter long. And such cables, how do you detect the inspect the cable? Nobody can climb the on that unless like you have some sort of a bucket which will move along the cable. So this sort of robots with some camera attached to it, that will be useful for the inspection of the cable. Now the third one is the unmanned aerial vehicle, or the drone, which can, we say that it can capture the photographs and also the bridge inspection data. In fact, CRRI is also in a project mode, trying to build one. Actually, our intention is first to, if we have something so that we can have the dimension of the various bridge components or bridges, because the drawings are to be created. That itself is a big task if we want to do it. Then another important aspect is that where this unmanned vehicle can be used, that is to inspect the fracture critical members of the steel bridges. Fracture critical member means that is a component in tension whose failure is expected to result in the collapse of the bridge. Okay, and fracture critical bridges, they are prone to fatigue cracking. But if we really want to do an inspection, you need some specialized equipment, operators, training. Then the MVAU sort of some trucks are required. Then the ND to detect the cracks on the surface. Then for that also you have to close the traffic lane. All such things are there. But for that, actually in US, what they have done is they have developed some this unmanned aerial aircraft system. Actually, like you can see that I am comparing 3 of them, and these 3 specifications are also there. And actually the Journal of Bridge Engineering ASCE during 2019 and 20, they published lot of papers on this. So what is happening now is that people are developing such system, and then they are validating the measurement taken using the sensors fitted to these US system with what a certified bridge engineer will do. Because in US, they have a certified bridge engineers are there. They only do the inspection of the bridge. And then they compare how accurate we are able to assess the health of the system. So what they found that the requirement is it has to be a small size, but it should be stable under wind and turbulence, and it should be able to position itself. And actually what happens now that when you go beneath a particular bridge, then the GPS will not work there. Okay, then it should have some sort of a laser ranger finder, and the camera should be attached so that its position can be oriented. Then it should have a adjustable light source and adjustable camera. That is, the camera should be able to the setting can be done to expose it and also to zoom it. So all these capabilities are required. And if you see that I am showing here 3 different types, and you can see that the DJI Mavic, the second one, that weighs only 0.74. Actually, the weight depends on what sort of sensors or payloads you are attaching to this. And this says that whether it is a quadcopter or octocopter, that is how many legs it has. You can see like our spider, like God also created something, and what we are trying to do is only to mimic what is there in the nature. And depending on the weight of the structure, weight of the sensors, what they have, like their flight time, which will be available, that is also limited, like 27 minutes or 16 to 22 minutes. So you have to understand, depending on what area you have to cover, what type of this system you have to select. That is also important. And the first one that cost something like $5,000, second one cost only $1,000, and the third one is less than $500. So there are different drones of various capabilities available, but the payload or the sensors, it can be attached to it, they are different. Okay, and they say that this DJI Mavic family that satisfied some of the requirements for the fracture critical bridge inspection. Okay, then what is the framework for the UAV inspection? Because it's not that very simple. Actually, it has different steps. We have to understand that. First is the data acquisition. Second is the 3D reconstruction. Third is the quality evaluation. It is not that you simply collect some data, but you have to see that whether the data is complete in all aspects, there is no noise there, or you may have to check whether there is some surface deviation or the geometry is accurate or not. All such things are there. And at the end, what you are getting is only you get the damage area extraction. That is where it is vectored and what is the damage size evaluation. Actually, how finely we will be able to measure the crack width, that is also quite questionable. Okay, now the first part, I would say that the data acquisition part, that is, we first have to see what is determine the areas to be covered, that is area of the structure to be covered and what information is to be collected. Okay, become familiar with the basic geographical information of the target and whether there is what is the traffic frequency, because you have to decide at what time I can deploy this particular vehicle for that or the drone for that, how far it is from the road, or whether there are some buildings and trees, because you should not lose this particular system.
Then if you may conclude,
Yeah.
Yeah.
Then you have to do the flight planning, then risk assessment, and you cannot simply use a drone. So you have to get the permission, and then you have to do the data collection. Then another method is that you can use a laser tracker, some sort of you can see it looks like a camera, but it consists of the AIFM and the ADM. So you will get both the distance, relative distance between 2 points, as well as you will be able to get the coordinate of the system. Again, you will see that the cost of the system that varies, and also the time required or the accuracies, all such things also varies. And there are now some small unmanned aircraft system are also being used for the inspection. And this system comes with some control panel, and the control panel has like you have a pilot to monitor the system, and also the inspector to see that, okay, he is getting the relevant data. And again, the unmanned aircraft system, like the control system may be kept on the ground beneath the bridge, or it may be mounted on a boat, or it may be there on a vehicle. So that detail you will get. And you can see that there are some non-contact technologies, because if you really want to install an LVDT, you need a very firm surface on which it firm support where it can be supported. So this laser tracker can be used to measure the displacement. Then another is the DIC method that can be used for the displacement. And the third one is the infrasound, that is the sound waves are going to be used to find out what is the frequency and mode of the vibration, from which you will be able to judge the health of the structure. Of course, it will provide a global health, and there are certain advantages, because the microphones are very easy to install. They don't require any calibration and other things, and lighting is not required. And so I have tried to cover. So what way forward I am suggesting is that actually the construction deficiencies are a big problem. So we have to have a SOP for construction of various type of bridges and culverts, because that is required, because though like the designers are very knowledgeable, but the people who are involved in the construction of bridges, they are not all of them are trained. Then we need trained and certified bridge inspectors. I think Sinha Sahab has suggested the numbers. Then the bridge management system will have to be adopted by the owners, but he suggested an institution. But how one institution will be sufficient, because we have different owners, like National Highway is owned by Ministry of Road Transport. There are state highways, there are rural roads. So how it can be done? That has to be thought about. Then automation of bridge inspection and non-contact technologies may have to be adopted in future, because our number of bridges are increasing in large number. We will have to do a standardization of structural health monitoring, because now people understand the requirement, but they don't know what is to be adopted or how to interpret the data. So standardization is required. The damage detection technique for interpretation of data collected from SHM. So all these things are required, because what we see the performance that need to go back to our codes which are used for the construction. Then only the future bridges will be saved, or their distresses can be minimized. So this is the suggestion from my side. And I'm very sorry. I think I took more time.
Man. It is really, we have got so much. Our participants have been sending so many messages that it is really worthy and engrossing lecture that they don't want to leave you.
That's right. I endorse that. I have been seeing that everyone is saying that it is so informative that possibly Only one speaker should have been sufficient for the entire workshop. Let me tell you this, Professor, and my compliments to you. Thank you
Thank
so
you,
much
sir. Thank you, sir.
for being so
Actually, sir, I
elaborate.
have been working in the area for quite some time.
We know.
And we ourselves, we do a lot of bridge inspection.
Yeah.
And so some sort of a feel I have.
This is
Though like I may not be, though I have gone to some of the inside the box girders also, but some places it is difficult for me to go also. So then again, I think about, okay, what system will be useful for a person like me to do the inspection of bridges.
No, excellent delivery, and you have done a wonderful work. And I think Dr. Chandan Ghosh, you can now summarize the things.
Her summary, she has very nicely, the last lecture, last slide itself indicates that I don't have to repeat, and she has given, it is just like a whole body scan of human body, like, you know, there are more than 5,000 or something, 500 or something disease that they can identify, and there are more than 150 plus blood tests are there. So she has covered almost all, and it is not only civil engineers, but it is also all vibration monitoring or even unmanned aerial vehicle, artificial intelligence, and then aerial survey, and then how it is to be correct, and with the precaution that yes, lots of automation has come. So we the damage detection technique for interpretation of data collected from structural health monitoring. That is a message that which is very strong. That with ETAP or many such software now, even anyone can give some data into the software and they can do the structural analysis. But that is not be there in case of health assessment. So that the message is very strong, and I think you, with your presentation and two more presentation that we had in the beginning, systematically that it is planned, our institutional approach to structural rating or infrastructure rating system with CRRI and CIDC, ICC, and all experienced engineers that we are having, I think it will take a big step towards perfection of bridge construction, design, inspection, monitoring, and retrofitting, everything. With artificial intelligence and new techniques that all are coming up with digital construction technology. So thank you, ma'am, for giving this much of time, your lifetime research that you have given to us, and which I hope that we are going to take it up very soon.
Thank you, ma'am, and it was wonderful. You had not only gone to the technical side of it, but you also advised what kind of prices prevail and how exactly people can get into learning how to use the UAVs. Matter of fact, CIDC has today the largest number of licensed pilots who are our trainers, and we are conducting the training program for different applications. May they be power plant inspection, or it could be the railroad inspection, or whatever you have. So that was lovely, and so many thanks to you for sparing so much of time. And I wish we would have had more time to listen to you. So as a sequel of this particular event, we'll certainly request you to come once again. And this time it is going to be a very, very longish session for you. And with that, I thank everybody, and let us meet tomorrow again. And there are some suggestions and instructions to everybody that 80% participation in the sessions is extremely important for anyone to get the participation certificate. That is something that everybody can note down. And today was the first day, so obviously we had to put the things in order. And tomorrow we'll be more disciplined in the sense that we'll keep ourselves muted and we will listen to that and listen to the wise speakers that are there. So hope to see you tomorrow. And I can see there are plenty of appreciation mails that have gone. People are asking for the copy of presentation. Let me tell you that this is all being run on the YouTube. It will be there. You are also having it on the Facebook. So I think we'll have all the material available. Otherwise, you can always write to CIDC. So thank you so much once again. remain safe, and very good night to all of you. And thank you all my speakers for all the patience and time that you have had. And many special thanks to Dr. Chandan Ghosh.
Thank you very much, sir. Thank you for giving the opportunity. And if some questions are there, definitely I will be able to answer them.
Professor, I think we have accepted your thanks, and we'll certainly have next opportunity when we'll try to kind of listen to you more. And Dr. Saab, it was wonderful. You did the coordination very ably. Thank you so much, and God bless you. Thank you.
Thank you, sir.
Thank you. See you tomorrow.
Thank you, sir.
Thank you very much.
Thank you.
Thank you, sir.
Yeah.
Yeah. नहीं कल परसों का कल परसों तक नहीं है, कल सवेरे तक दोपहर तक भी का नहीं है, सिर्फ 3-4 डायपर वो कह इसी दिन भी आ सकता है, कल सवेरे भी आ सकता है। ठीक है, नहीं तो फिर यहाँ से मंगा देना इमरजेंसी हुई एकदम लास्ट मिनट पे क्यों रखते हो यार, पार्टियां की हैं अभी इतनी, एक पैकेट